Hello everyone, welcome to Pushpa classes. So today we will start our new topic, that is Routh Hurwitz criteria. ये एक इम्पॉर्टेंट टॉपिक है फॉर योर एग्ज़ाम पॉइंट ऑफ व्यू. अगर आप प्रीवियस ईयर क्वेश्चंस को रेफ़र करोगे तो आपको मिलेगा कि इस टॉपिक से रेगुलर बेसिस में क्वेश्चंस पूछे गए हैं इन योर गेट एग्ज़ाम, ESE एग्ज़ाम एज वेल एज इन योर डिफरेंट PSU एग्ज़ाम. ठीक है. अगर हम लोग डिफ़िकल्टी लेवल का बात करें तो ये टॉपिक बेसिकली हम लोग एक इजी कैटेगरी में फॉल करवाते हैं. ऐसा मीन्स कहना है मतलब टीचर्स एंड स्टूडेंट्स का कि राउथ हर्विट्ज क्राइटेरिया इज़ बेसिकली अ इजी टॉपिक टू स्कोर मार्क्स. ठीक है. अब देखो, अगर कोई टॉपिक इजी होता है ना तो उसके साथ एक लायबिलिटी क्या आ जाता है कि उस टॉपिक से अगर एग्ज़ाम में क्वेश्चंस पूछे गए हैं तो आपको एनी हाउ उस क्वेश्चन को सही सॉल्व करना पड़ेगा. क्योंकि अगर आप इजी टॉपिक को सॉल्व नहीं कर पाए तो फिर बाकी स्टूडेंट के कंपेयर आप काफ़ी पिछड़ जाओगे और फिर कैचअप करना बहुत डिफ़िकल्ट हो जाता है. इसलिए इजी टॉपिक के साथ हमेशा ये लायबिलिटी आपको लेकर चलना पड़ेगा कि अगर कोई टॉपिक इजी है तो आपको ये मेक श्योर करना है कि किसी भी तरह वो टॉपिक आपसे गलत ना हो जाए. अब अगर इजी टॉपिक है और आपको उसको एनी हाउ सही करना है तो ये कैसे हो सकता है? इसके लिए क्या है कि जो भी कॉन्सेप्ट या जो भी टेक्निक उस टॉपिक से लिंक्ड है वो आपको बिल्कुल अच्छे से समझना पड़ेगा, जिससे आप एग्ज़ाम में सिली मिस्टेक ना कर लो. ठीक है. इसी तरह अगर हम लोग राउथ हर्विट्ज क्राइटेरिया का बात करें तो ये टॉपिक है तो इजी, लेकिन यहाँ पे ना अराउंड 3 से 4 बहुत इम्पॉर्टेंट ट्रिक्स है, कॉन्सेप्ट है या फिर आप टेक्निक कह लो जो आपको पता होना चाहिए. अगर वो ट्रिक्स एंड टेक्निक्स आपको पता है फिर तो ये टॉपिक बिल्कुल इजी है एंड हाई स्कोरिंग है. लेकिन अगर वो ट्रिक्स एंड टेक्निक्स आपको नहीं पता है या फिर उसको आप एग्जीक्यूट करने में गलती कर दिए, फिर ये टॉपिक से आप सिली मिस्टेक कर सकते हो. ठीक है. तो मैं आपको इस टॉपिक को कैसे पढ़ाऊंगा? मैं आपको इस टॉपिक को बिल्कुल कम्प्रिहेंसिव मैनर में पढ़ाऊंगा. जितने भी ट्रिक्स टेक्निक्स या फिर कॉन्सेप्ट का मैं बात कर रहा हूँ वो मैं आपको बहुत अच्छे से बताने वाला हूँ. आपको क्या करना है कि वो सारे चीज़ों को बहुत अच्छे से ध्यान से सुनना है और समझना है. ठीक है. मैं इस लेक्चर में मीन्स आपको बहुत सारे क्वेश्चंस भी करवाने वाला हूँ फॉर योर प्रैक्टिस सेक. तो थ्योरी देखकर एंड क्वेश्चंस देख के जो भी ट्रिक्स एंड टेक्निक्स है वो तो आप अच्छे से समझ लोगे और आप उसको एग्जीक्यूट करना भी सीख जाओगे. बस आपको फिर क्या करना है कि कुछ आप प्रीवियस ईयर क्वेश्चंस उठाना या फिर कुछ टेस्ट सीरीज उठाना, प्रैक्टिस करना और आपको ये मेक श्योर करना है कि इस टॉपिक से अगर क्वेश्चंस आ रहा है तो वो आपसे गलत ना हो जाए. ठीक है. तो चलो हम लोग अपने राउथ हर्विट्ज क्राइटेरिया टॉपिक को स्टार्ट करते हैं. Now, coming to Routh Hurwitz stability criteria. So in Routh Hurwitz stability criteria, it is important to note that this criteria is not related to control system. This criteria is related to any higher order polynomial. This criteria is related to any higher order polynomial to determine location of poles, to determine location of pole, or we can say to determine location of root with respect to any reference plane, with respect to any reference plane. This criteria doesn't give us the exact location of roots. It doesn't give us exact location of root, but it helps us in determining location of roots, but it helps us in determining location of roots with respect to a reference plane, with respect to a reference plane. Now see why this criteria is very important and why this criteria is used in control system. Why this criteria is used in control system? Suppose we have a polynomial like this: s square plus 5s plus 6 is equal to 0, and we are asked to find to determine location of roots. To determine location of roots, then we can easily solve this equation. Then we can easily solve this equation to find or determine the location of roots. To determine location of roots, 2s plus 3. So it will come out to be s plus 2. Very simple quadratic equation to find the roots of this quadratic equation, and the roots are -2 and -3. -2 and -3. Fine. But now suppose if you are given a polynomial like this: s8, s7, s6, s5, s4, s3, s2, s. Now suppose we are given a quadratic equation. Now suppose we are given a not a quadratic equation, but now suppose if you are given a higher order polynomial to get solved. So can we find roots of this equation? Can we find roots of this equation? Yes, we can find roots of this equation. There are techniques to find roots of these equations, but it will take a very long time. But it will take a very long time. But it will take a very long time. But if someone asks you that I don't want exact location of roots, I don't want exact location of roots, you just tell me the location of roots with respect to a reference plane. You tell me location of roots with respect to a reference plane. Suppose we have a reference plane that is S plane. Suppose we have a reference plane of S plane, and if it is asked to just give me this information that how many roots are lying in the LHS of S plane and how many roots are lying in the RHS of S plane, then in that criteria where we just have to find a number of roots lying at the left hand side of a reference plane or number of roots lying at the right hand side of a reference plane, and we don't have to find out the exact location of roots, and we don't have to find the exact location of roots. In that case, this Routh Hurwitz stability criteria is very useful, and it is very efficient to find out the result in a very minimum time. In a very minimum time. So I hope this is clear. Now coming to properties. Now coming to properties of Routh Hurwitz criteria. Properties of Routh Hurwitz criteria. Coming to the first property. See, we can write, which we have already discussed also, for lower order system, it is easy. For lower order system, it is easy to determine location of roots or location of poles, as we say in control system, to determine location of roots, or we can also say poles. We have also seen it in our example that if we are given a second order quadratic equation, how easily we can determine the location of roots or poles. But for higher order polynomial, higher for higher order polynomial, but for higher order it will become difficult. It will become difficult. We can find it, but it will take a lot of time. We can find it, but it will take a lot of time to determine location of roots. It will become difficult to determine location of poles, location of roots, or location of poles. So we go for Routh Hurwitz criteria. So we go for Routh Hurwitz criteria, where we can easily find positioning of roots, or poles with respect to reference plane. In control system, we are using the reference plane as S plane. For control system, we are using reference plane as S plane. From Routh Hurwitz criteria, you can change the line. These are the statements which you should remember, which you should remember, and if it's asked in conventional, then you can write it properly in an elaborate manner also, like this. From Routh Hurwitz criteria, from Routh Hurwitz criteria, we can't determine exact position. We can't determine exact position of poles, but we can easily find positioning, positioning of poles with respect to a reference plane, with respect to a reference plane, which is sufficient, sufficient to determine, which is sufficient to determine absolute stability. Absolute stability. That is from Routh Hurwitz criteria. That is from Routh Hurwitz criteria, we can find absolute stability. We can find absolute stability very easily. Very easily. From Routh Hurwitz criteria, we can find a relative stability also. From Routh Hurwitz criteria, we can find relative stability also, which we will see in coming session, which we will see in coming session. And there I will tell you that why Routh Hurwitz criteria is not a very useful tool for finding relative stability, because it's a very time consuming process. So that's why Routh Hurwitz criteria is used to find absolute stability, and it is not used to find relative stability, though we can find relative stability from Routh Hurwitz criteria, but as it is very time consuming, so we don't go for relative stability. So we don't go for finding relative stability using Routh Hurwitz criteria. So here now we have seen a important term, absolute stability, and I was also discussing relative stability. So what is this absolute and relative stability? This absolute and relative stability, this also I will discuss in details in coming session. But here we can understand it by a simple example. But here we can understand it by a simple example. Suppose suppose an exam is conducted. Suppose an exam is conducted, and you have to just evaluate that how many students have passed the exam and how many students have failed the exam. Then such condition is known as the absolute stability. Such conditions are known as the absolute stability, because you just have to say that out of 50, so much students have passed the exam, and out of 50, so much students have failed the exam. But suppose if you are asked to not only find how many students have passed or failed the exam, but also to give rank to each student, but also to give rank to each student, but also to give rank to each student. In that case, we cannot give our result in form of absolute stability, but in that case we will give our result in terms of relative stability. Relative stability. Similarly, in control system also, if you are given 5 routes or poles, and you are asked to find that how many poles are lying only and that how many poles are lying in the left hand side of S plane and how many poles are lying in the right hand side of S plane, then we can easily use Routh Hurwitz criteria and find the absolute stability But if you are asked to find the exact location of roots, on the S plane, and based on this, if you are asked to find the exact location of roots on S plane, and based on that you have to find that which system or which pole is more stable with respect to other pole, then in that case you have to go for relative stability. But in that case you have to go for relative stability, and for that Routh Hurwitz criteria is not a useful tool, because it's a very time consuming tool. For that we go for frequency response, and we go for Nyquist plot and all that we will see in details in our further session. So I hope this term absolute stability and relative stability is clear to you, but we will discuss it in details more in the upcoming session. Now coming to second property. If I talk about what is objective of Routh Hurwitz criteria? If I talk about what is objective, what is objective of Routh Hurwitz criteria? Objective of Routh Hurwitz criteria. Objective of Routh Hurwitz criteria. So if we want, objective, we can say that objective of Routh Hurwitz criteria is to determine, objective of Routh Hurwitz criteria is to determine, determine closed loop stability, closed loop stability, closed loop stability of control system, of control system without finding, without finding, without finding roots of characteristic equation, without finding roots of characteristic equation, characteristic equation. So, objective of Routh Hurwitz criteria is to determine closed loop stability of control system, closed loop stability of control system without finding roots of characteristic equation, without finding roots of characteristic equation. Now coming to next point, and that is how this Routh Hurwitz criteria works. How this Routh Hurwitz criteria works, that is how the objective of determining closed loop stability without finding roots of characteristic equation works. How the objective of determining closed loop stability without finding roots of characteristic equation works. So according to RH criteria, according to RH criteria, Routh Hurwitz criteria for closed loop, for closed loop system, for closed loop system to be stable, to be stable, to be stable, it is necessary, it is necessary and sufficient. It is not only necessary, but it is also sufficient. This term plays an important role in Routh Hurwitz criteria. Not only in Routh Hurwitz, this term plays an important role everywhere. That whether because some conditions are necessary but not sufficient, and some conditions are necessary as well as sufficient. It is necessary and sufficient that all the elements, that all the elements of first column of Routh array, of Routh array must have same sign, must have same sign. If no row of Routh array, if no row of Routh array is zero completely, is zero completely. So according to Routh Hurwitz criteria, for closed loop system, to be stable, it is necessary and sufficient. It is necessary and sufficient that all the elements of first column, of Routh array must have same sign, if no row of Routh array is zero completely. If no row of Routh array is zero completely. So in continuation of this, we can write one more point. That is, if there is sign changes, then system is unstable, and the number of sign change indicates number of closed loop poles, in right hand side or right hand half of S play. See here what we wrote, that according to RH criteria for closed loop system to be stable, it is necessary and sufficient that all the elements of first column of Routh array must have same sign, and here we are writing that if all the elements of first column of Routh array is not having the same sign, that is, if there is sign changes, then system is unstable. And number of sign change indicates number of closed loop poles, in right hand side of S plane, So now enough of the theory. Let's see what is this Routh array. How this Routh array is formed. What is this first column? What is this having same sign? What is this having sign changes? What is this that is sign changes? And then later we will discuss that what is this that no row of Routh array is completely zero. Let's see all these things by taking some practical examples. What is this Routh array and how it is formed? Suppose we are given a fourth order polynomial equation. Suppose we are given a fourth order polynomial equation, A4S4, A3S3, A2S2, A1S1, A0S0. we are given a fourth order polynomial equation and we are asked to form Routh array, and we are asked to form Routh array. Then see how it is formed. First we will write all the order of S. First we will write all the terms of S. First we will write all the terms of S from higher order to lower order. From higher order to lower order. So first we will write S4, then S3, then S2, then S1, then S0. So first all the order of S are written. First all the order of S are written, and they are written in higher order to lower order. Higher order to lower order. Now we will write coefficients of all the order of S. Now we will write coefficients of all the order of S. So here S4. So here A4 will come. Here A4 will come. Here A4 will come. Here coefficients of S4. This is the coefficient of S4. This is the coefficient of S4. Here the coefficient of S3 will come. Here coefficient of S3 will come. Now here coefficient of S2 will come. Here coefficient of S1 will come. Here coefficient of S0 will come. In Routh array, for a particular row, the coefficients are written alternatively. The coefficients are written alternatively. That is, if this is the coefficient of S4, then after this from S4 we will get S2, and from S2 we will get S0. From S2 we will get S0. Similarly, this is the coefficient of S3. So from S3 we will get S1. We will get S1. Because see how it is going in, how in which sequence we are going in Routh array. We are going like this. We are going like this. This is A4 S4, then A3 S3, then A3 S3, then A2 S2, A2 S2, A1 S1, A1 S1, A0 S0, A0 S0. I hope this is clear to you. I hope this is clear to you. And here we will get 0. And here we will get 0. Now come into S2. Now come into S2. So here we will multiply it this minus this. That is, here we will get A3 A2 minus A4 A1 divided by this. Divided by this. This into this minus this into this, divide by this term. Divide by this term. Now come into the here. Now come into this part. Now come into this part. We will have to multiply it like this. Now we will multiply A3 A0, A3 A0 minus A4 0 by A3. That is, we will write it like this. A3 A0, A3 A0 minus A4 into 0 by this term only. By this term only. By this term only. Now here we are having 0 and 0. So if we want to write this term, then what we will get? We will get it like this. A3 into 0, A3 into 0 minus A4 into 0, A4 into 0, A4 into 0, divide by A3, divide by A3. That is, we will get 0 here. That is, we will get 0 here. That is, we will get 0 here. So now coming to, now for simplification, let us assume, let us assume this term as P1. Let us assume this term as P1, and let us assume this term as P2. Let us assume this term as P2. Now see, if we want to find this coefficients of S1, then see how we will proceed. How we will proceed? We will move like this: P1 into A1, P1 into A1 minus A3 into P2, A3 into P2 divide by P1. That is, we will write it here: P1 A1 minus A3 P2 divide by P1, divide by P1, divide by P1. Here we will get 0, here we will get 0, because see what we will get, we will get P1 into 0, P1 into, here we will get, if I want to show you, P1 into 0, P1 into 0 minus A1, minus A1, A3, minus A3 into 0, minus A3 into 0 by P1. Here we will get 0. 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 Now coming to S0. Now coming to S0. What we will get here? We will get this term into P2, this term into P2 minus P1 into 0, minus P1 into 0 divide by this term, that is, ultimately we will get P2 here. That is, ultimately we will get P2 here. That is, ultimately we will get P2 here. So this is how Routh array is formed. So this is how Routh array is formed. See, I have made a lot of arrows here. You will obviously get confused, but you listen that what I was telling, and now obviously we are going to take a number of examples, and it will be very clear to you, and you will not require to remember all these arrows, that from where to where you have to go. By solving 2 to 3 questions, you will get accustomed, or you will get used to it. So now, where is my first column? So now, where is my first column, which is of so much importance? Where is my first column, which is of so much importance? This is my first column. This is my first column, and these are the elements of first column. This is my first column, this is my first column, and these are the elements of my first column. So if I want to write, my first column, if I want to write my first column separately, just for demonstration point of view, I am writing this column separately. In exam point of view, you don't have to write anything separately. Just after finding the elements of first column, you can determine that whether my system is stable or not, and how many poles are lying on the LHS or RHS. So what are the elements of first column? So what are the elements of first column? It is A4, A3. This term we have considered P1. This term we have considered P1. This term, let us assume it as, let us assume this term as Q1. Let us assume this term as Q1. This is Q1 and last term is P2. Last term is P2. Now for system to be stable, all the elements of first column, must have same sign. All the elements of first column, must have same sign, that is there shouldn't be any sign change, because there shouldn't be any sign change. And if there are sign change, then number of sign change gives us the information of number of roots lying in the right hand side. That is, suppose if I consider A4 to be positive, that is, suppose I consider this A4 to be positive, then for system to be stable, A3 should also be positive, P1 should also be positive, Q1 should also be positive, P2 should also be positive. Then only my system will be stable. And all the roots here, the highest order here the highest order of polynomial is 4. Here the highest order of polynomial is 4. That is, there are 4 roots or 4 poles in this polynomial equation. That is, there are 4 roots or 4 poles in this polynomial equation. So in this case, if all the elements of first column is greater than 0, that is positive, then my system is stable and all the 4 roots or all the 4 poles are lying in the left hand side of S plane. Now suppose my A4 was negative, that is less than 0. Then in that case, my A3, for system to be stable, A3 should also be negative, P1 should also be negative, Q1 should also be negative, P2 should also be negative. That is, there shouldn't be any sign change. All the elements of the first column should have the same sign. Either it may be positive or it may be negative. It is not necessary that all the elements of first column will be positive, only then the system will be stable. It is not necessary. All the coefficient of first column should have same sign. It can be either positive or negative. So here also, as all the elements of first column are having the same sign, that is all are negative, so our system is stable. That all the 4 that is all the 4 roots of polynomial equation is lying in the left hand side of S plane. Now suppose if there is a sign change. Suppose there is a sign change. Suppose A4 is positive. Suppose A3 is positive. Suppose P1 is negative. Suppose Q1 is positive and P2 is negative. Suppose A4 is positive, A3 is positive, P1 is negative, Q1 is positive, P2 is negative. Then see, how many sign changes are there? First, this, from positive to negative, first sign change. Then this, from negative to positive, second sign change. Negative to positive, second sign change. And here, positive to negative, third sign change. positive to negative third sign change. That is, here we are having three sign changes. That is, here we are having three sign changes. So we can say that we can write it like this: total poles 4, poles on LHS, poles on RHS. So how many poles will be on the right hand side of S plane? It is equal to number of sign change. The number of sign change, gives us the information of number of roots or poles lying in the right hand side. So we will write it 3 here because there are 3 sign change. So now how many poles are remaining? How many poles are remaining? One pole is remaining, and where it will lie? It will lie on the LHS. It will lie on the LHS. It will lie. It will lie on the LHS. This is the significance of Routh array. From this slide, we have seen that how we can form Routh array, how we can form Routh array. From this slide we have seen how we can form Routh array, from Routh array, how we can find elements of first column, from Routh array, how we can find elements of first column, and from elements of first column, or based upon the sign of elements of first column, we can determine how many roots are lying in the left hand side of S plane, how many roots are lying in the left hand side of S plane, and how many roots are lying in the right hand side of S plane, and how many roots are lying in the right hand side of S plane. Now let's take an example. Then things will be clear to you. Suppose take an example of, we will take fifth order polynomial equation. So S5, I am going to take any random coefficients, S5, S4, 2S3, 3S2, 4S1, 1, 1S0, 0. Now we will form the Routh array. So we will write terms of S. So we will first write terms of S starting from higher order to lower order. Starting from higher order to lower order. Fine. So first we will write coefficient of S5. Then we will move alternatively. So coefficient of S3 will come here. Then we will move alternatively. So coefficient of S1 will come here. And now there is no term. Now coming to the second row. So we will write coefficient of S4. Then we will move alternatively. So coefficient of S2 will come here. Then we will move alternatively. So coefficient of S0 will come here. Now we will complete this Routh array. Now we will complete this Routh array. So we will move like this: 1 into 2 minus 3 into 1 by 1. That is 2 minus 3 by 1. Now for this, 1 into 4, 1 into 4 minus 1 into 1, 1 into 1 by 1. 1 is to 4 minus 1 into 1 by 1. Now here we are having 0, 0. So 1 is to 0, 1 is to 0 minus 1 is to 0, 1 is to 0 by 1. We will get 0 here. We will get 0 here. We will get 0 here. So if I want to simplify it, what we will get? We will get minus 1 here. We will get minus 1 here, and this, it will be 3. It will be 3, 0, 0. Now coming to this, so it will be minus 1 into 3, minus 1 into 3, minus 3, minus 1 into 3, minus 1 into 3, minus 3 by minus 1, minus 1. Here what we will get? Minus 1 into 1, minus 1 into 1. So minus 1. 1 into 0 will be 0 by minus 1, by minus 1. So by simplifying, what we will get here? We will get here minus 6. We will get 6 here. This is 6. This is 6. And what we will get here? We will get here 1. We will get here 1. Now coming to coefficient of S1, then 6 into 3, 6 into 3, 18, minus 1 into 1, plus 1 by 6, by 6. And now these terms are 0, so this in 6 into 0 minus 1 into 0 by 6, we will get 0 here. So what will be this? It will be 19 by 6. 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 Now what will be coefficient of S0? This into this, this into this, minus this into this into this, divide by this, that is we will get 1 here. 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 Now we are interested with only the first column. Now we are interested with only the terms of first column or coefficients of first column, and in that also we are interested in number of sign changes, and in that also we are interested in number of sign changes, and in that also we are interested in number of sign changes. So it is a fifth order polynomial equation. So total poles we know it is 5. We have to find now poles on LHS. We have to find poles on RHS, and then we will comment whether this system is stable or not. And then we will comment whether this system is stable or not. This is my, suppose this is my characteristic equation of closed loop control system. This is my characteristic equation. This is my characteristic equation. This is my characteristic equation of closed loop control system. Of closed loop control system. So now see how many sign changes are there. One sign change is there. One sign change is there. Two sign changes are there. Two sign changes are there. So number of sign change is equal to number of poles on right hand side. So number of sign change is equal to number of poles on right hand side of S plane. So there are 2 poles on right hand side of S plane. So there are 2 poles on right hand side of S plane. Now number of poles on left hand side of S plane will be 5 minus 2, that is 3. That is remaining poles will come on left hand side of S plane. Now confirm whether this system is stable or not. Now confirm whether this system is stable or not. So what we are having? We are having, suppose these two roots are here and these three roots are here. 3 roots on the LHS, 2 roots on the RHS. So this system is unstable. So this system is unstable because there are poles at right hand side of S plane. This system is unstable because there are poles on right hand side of S plane. Because there are poles on right hand side of S plane. Because there are poles on right hand side of S plane. Because there are poles on right hand side of S plane. Now coming to another example, let us take another example, and here I will give you a shortcut, that is how you can simplify your calculation while forming Routh array. So it is a 4-order polynomial equation. So first we will write all the terms of S. Starting from higher order to lower order. S2, S1, S0. So first we will write coefficient of S4. Then we will move alternatively. Here 8 will come. Now we will write coefficient of S3 here. 8 will come here. Then we will move alternatively. Then here it is 0. Now see the shortcut. Here we can say that it is, here we are getting 8, here we are getting 16, here we are getting 0. That is, we can divide this row, by 8. By dividing this row by 8, what we will get? We will get 1 here, we will get 2 here, and it will be 0 only. So by by dividing this row by 8, our coefficient is now 1, 2 and 0. Earlier it was 8, 16, 0. So now my calculation will become little easier. Because we don't have to multiply 8 into 18 and 1 into 16, then we have to take subtraction and then we have to do division. 1 into 18 and 2 into 1 divided by 1, this all figures, in terms of 1, 2, 3, 4, they are easy in simplification as respect to higher numbers. So this is the shortcut. That if in a particular row, you are able to simplify the numbers in that row. If you are able to simplify the numbers in that row by dividing it with some numbers, by dividing it by some numbers, then you should do it. So now in place of 8 I will write 1. So now in place of 8 I will write 1, and in place of 16 I will write 2. In place of 16 I will write 2, and in place of 0 I will get 0 only. Now start the calculation. 1 into 18, 18 minus 2 by 1. Here 1 into 8 minus 0 by 1. This into this into this by this, 0 0, it will come 0. Now again simplify it, it will be 16. It will be 16 here, it will be 16 here, and this we will get as 8, and this we will get as 8, and this we will get as 8. Fine. Now continue this calculation. It is 16 into 2. Now, here again, see, we can use the shortcut. Here again, see, we can use the shortcut, because if we talk about the S2 row, because now if we talk about the S2 row, so we are having 1680. That is, we can divide this S2 row by 8 again. We can divide this S2 row by 8 again for simplification. For simplification. For simplification. Then see, if I divide 16 by 8, here I will get 2, here I will get 2, and here I will get 1, and here I will get 1. Now again continue the calculation. 2 2 to 4, 4 minus 1 by 2, and here I will get 2 into 0, 1 into 0, here I will get 0. So what it will be this? 4 minus 1 by 2, 3 by 2, 1.5. 1.5. Now continue the calculation. 1.5 into 1 minus 2 into 0 by 1.5, I will get 1. Fine. So this was the shortcut. So this was the shortcut. That is, if you have a row, that is, if you have a row where you can divide all the terms, please keep in mind that all the terms should be divisible by that particular number, because see, here also we are getting 1, 18 and 8. You will say that we can divide 8 by 2 and 18 by 2, but we cannot do so, because we cannot divide 1 by 2, because we cannot divide 1 by 2. So all the elements should get divided. So all the elements of that particular row, so all the elements of that particular row should get divided by that particular number, by that particular number. All the elements, I can write it, all the elements of a particular row, all the elements of a particular row should get divided, should get divided, should get divided by that number, by that number. Keep this shortcut in mind. Keep this shortcut in mind. It will simplify your calculation. It will simplify your calculation, but don't get confused. But don't get confused. For a particular row, all the terms of that particular row, all the terms of that particular row should get divided. All the terms of that particular row should get divided. Fine. Now coming to the result. Now coming to the result. Total poles. Total poles 4. Poles on LHS we have to find. Poles on RHS we have to find. Then we have to comment on the stability. Then see, first we will find total number of sign change in the first column. First we will find a total number of sign change. First we will find a total number of sign change in the first column. Is there any sign change? No, there is no sign change. So total number of poles on the right hand side will be 0. So total number of poles on the right hand side will be 0. So now total number of poles on the left hand side will be 4 minus 0, that is 4. That is, all the poles are lying in the left hand side of S plane. Therefore my system is stable. Therefore my system is stable. Therefore my system is stable. So I hope now you are comfortable in forming this Routh array, and then commenting on the stability of the system, based upon the sign change of first column of Routh array. Based upon the sign change of first column of Routh array. Now, coming back to properties of Routh Hurwitz. Now, coming back to properties of Routh Hurwitz, then now we will discuss one very important property. Now we will discuss one very important property. There's lot of doubt and confusion in the mind of a student regarding this property, because of which you make silly mistake, because of which you make silly mistake. Then this property is like this. Then this property is like this, that all the coefficient, all the coefficient of characteristic equation are non-zero if all the coefficient of characteristic equation are non-zero and have same sign and have same sign if all the coefficient of characteristic equation are non-zero and have same sign, then it is necessary, but then it is necessary but not sufficient, but not sufficient condition for stability, but not sufficient condition of stability. See, most of you must be having this misconception. Most of you must be having this misconception that if all the coefficients of characteristic equation are non-zero, that is, if all the coefficient of characteristic equation are non-zero and they have the same sign, then that system is going to be stable. Then that system is going to be stable. It is not that. This condition, that is all the coefficient of characteristic equation to be non-zero and all the elements or all the coefficients of characteristic equation must be having the same sign, is a necessary condition of characteristic equation. It is a necessary condition of characteristic, is a necessary condition for stability, is a necessary condition for stability, but it is not sufficient condition, for stability of a system. That is, what is difference between necessary and sufficient? Necessary is the minimum condition. Necessary is the minimum condition which has to be achieved, but it doesn't guarantee stability. That is, if we are having a characteristic equation, suppose S4, S3, 2S2, S1, S0 is equal to 0, then here we can see that all the coefficients are non-zero. After S4 we are getting S3, S2, S1, S0. So all the coefficient of characteristic equation are non-zero and all the coefficients are positive, This is a minimum necessary condition. Required for stability of a control system. But it does not guarantee you that a system is stable. For concluding the stability, you have to form Routh array. and then only you can comment on the stability. That is, if we take this example, see here also none of the coefficients are zero. See here also none of the coefficients are zero, and all the coefficients are having the same sign, and all the coefficients are having the same sign. That is, all the coefficients are positive, but still our system was not stable. So this is a perfect example that all the coefficients are non-zero and all the coefficients are having same sign, but it is still unstable, because this is a minimum necessary condition, because this is a minimum condition for stability, but this is not the necessary condition, for stability. Now suppose we have another example like this. This was my first example, and suppose we are having another example like this: S4 minus S3 plus 2S2 plus S1 plus S0. Here we can say that all the coefficients of characteristic equation are non-zero, but all the coefficients are not having the same sign. All the coefficients are not having the same sign, because here we are having positive, then negative, then positive, positive, positive. Then for this system we can directly conclude without forming the Routh array that this system is my unstable system. This system is my unstable system. For this system we cannot conclude whether it is stable or unstable, because we have to form a Routh table to conclude its stability and instability. But for this equation we can directly conclude that it is unstable, because all the coefficients are not having the same sign. Now suppose if we take another example like S4, then S2, then S1, then S0 is equal to 0. See here all the coefficients are having the same sign, all the coefficients are positive, but here all the coefficients of characteristic equation are not non-zero. After S4 we can see that S3 term is missing. After S4 we are getting S2, S1, S0, but S3 term is missing. One term is missing. That is, by looking at this equation we can directly say that it is unstable. So from this we can conclude a very important property, that if all the coefficients of characteristic equation are non-zero and have the same sign, then it is a necessary condition, because see here the all the coefficients were not having the same sign, so it become unstable, as one of the coefficient or order of S was missing, so it is unstable. So this condition, all the coefficient of characteristic equation to be non-zero and having the same sign, is a necessary condition. Without this condition my system will be definitely unstable. But even if these conditions are met, then it doesn't guarantee that my system is stable. For that we have taken one example also. For such a characteristic equation where both these properties are met or conditions are met, still we have to find a Routh table. For concluding the stability. We can elaborate this property a little further. By saying that positiveness positiveness of coefficient of characteristic equation, positiveness of coefficient of characteristic equation guarantees that real roots real roots of system that real roots of system are lying on the left hand side of S plane, but but we cannot comment or conclude of complex roots that is, we can say that if all the coefficients of characteristic equation are having same sign, or we can say that if all the coefficient of characteristic equations are positive, not same sign, but we should say that if all the coefficient of characteristic equations are positive, if all the coefficients of characteristic equation if all the coefficients of characteristic equation are positive, then my real roots will lie on the left hand side of S plane. This we can conclude confidently, that all the real roots will obviously lie and will definitely lie on the left hand side of S plane, but we cannot comment or conclude anything about the complex root. That is, we cannot say that where my complex roots are lying. It may lie either on the left hand side of S plane, or it may also lie on the right hand side of S plane. That is, it may lie on left hand side of S plane, or it may also lie on right hand side of S plane. Suppose for example, we have taken this this polynomial equation. Suppose for example, we have taken this polynomial equation. Here we can see that all the coefficients of characteristic equation are positive. That is, all the coefficient of characteristic equation are positive. And if we will find its root, then its roots will be -5 to plus minus 4.5z. You can calculate it by using calculator, and you will find the roots like this: -5 and to plus minus 4.5j. So here this statement is confirmed, that if all the coefficients of characteristic equation are positive, I am saying positive, not same sign, I am saying positive. If all the coefficients of characteristic equation are positive, then my real root will definitely lie on the left hand side of S plane. Then my real root will definitely lie on the left hand side of S plane. But here we can see that my complex root is lying on the right hand side of S plane. My complex root is lying on the right hand side of S plane, and because of this complex root only, for real root it is definite that it will lie in the left hand side of S plane. But we cannot say that my system is stable for the if the coefficients of the equations are positive, because we cannot comment anything on the complex roots. Sometimes it may lie on the left hand side, and sometimes it may lie on the right hand side. Sometimes it may lie on the left hand side, and sometimes it may lie on the right hand side. That's why we cannot confirm that if all the coefficients of polynomial equations are positive, then my system is definitely stable. We cannot comment like this. For this, we have to find the Routh array. We have to find the Routh array. We have to find the elements of first column. We have to find the elements of first column. And then only we can comment that whether my system is stable or not stable. And then only we can comment whether my system is stable or not stable. And similar sort of example we have seen here also. And similar type of example we have seen here also. Now coming to special cases. Now coming to special cases of Routh criteria. Now coming to special cases of Routh criteria. There are two special cases, and these two special cases are very important for your exam point of view. And you should know it very well. I'm going to give you a number of short tricks here also, which will make it easier for your understanding purpose as well as for solving questions in exams. So coming to special cases of Routh criteria. Coming to case 1. Coming to case 1. Now, first I will write the statement. Then we will take some examples. While forming Routh array, first element in any row, first element in any row may result into 0, and in that row there must be at least one non-zero. There must be at least one non-zero element due to which the Routh array ends abruptly. Now, to overcome this difficulty, to overcome this difficulty, we will replace the zero with a term a such that limit a tends to 0. That is, a is tending to 0. And sign of a is same as sign of element of previous row. or we can write and sign of A is same as sign of first element, first element, first element, first element of previous row. See what I am saying it here, that while forming Routh array, suppose if first term, first element in any row becomes 0, it becomes zeros, it becomes 0 and it becomes 0, and in that row there must be at least one non-zero element, due to which the Routh array ends abruptly, because we know that in the denominator part we use the first element of each row. So that's why the Routh array will end abruptly. To overcome this difficulty, we will replace 0 with a new term A, such that A is tending to 0, and sign of A is same as sign of first element of previous row, and sign of A is same as sign of first element of previous row. So this is one special condition of Routh criteria. This is the statement. I know that it is not much clear to you now, but let us take some example and then it will be easily clear to you. Let's take an example. Based on this concept or based on this special case. Suppose characteristic equation is given as S5, S4, 2S3, 2S square, 3S plus 15 is equal to 0. Now we will form Routh array. We will get S5, S4, S3, S2, S1, S0. So coefficient of S5 is 1. Then we will move alternatively 2, 3. Coefficient of S4 is 1. Then we will move alternatively 15. Now see what will come here. 1 into 2 minus 1 into 2 by 1, that is 0. What will come here? Here 1 into 3 minus 1 into 15 by 1, that is minus 12 will come here. And here we are having 0, 0. So here we will get 0. Then see, is this satisfying our first special case? Is this satisfying our first special case? Yes. Why? Because first element of any row, here S3 row, first element of any row, that is here S3 row, is 0, and there is at least one non-zero element, in this row, and there is at least one non-zero element in this row. So it is satisfying our first special case. So it is satisfying our first special case. So in this case we will assume, we will replace this term by A. We will replace this term by A, where A is tending to 0, where A is tending to 0, where A is tending to 0. And what will be sign of A? Sign of A depends upon the first element of previous row. Sign of A depends upon the first element of previous row. Sign of first element of previous row is positive +1. So A will also be positive. 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 Suppose in place of +1, we had -1. If we had -1, then in that case, sign of A would have been -1. Yeah, sorry, in that case, sign of A would have been negative. In that case, sign of A would have been negative. So I hope that this is clear, that how we can determine sign of A, and how we can replace the 0 element with A tending to 0, with A tending to 0. Now we will complete the Routh array. Now we will complete the Routh array. So we will get 2A plus 12 by A. Here we will get 15A by A, that is we will get 15. Now this part we will write it like this: minus 12, 2A plus 12 by A, plus 15A by 2A plus 12 by A. Fine. Now coming to S0, here we will get 0. Coming to S0, we will get this into this into this, minus this into this by this, that is we will get 15 here. That is we will get 15 here. Now we will check first column of this Routh array. Now we will check first column of this Routh array. Then see, it is positive. It is positive. A is also positive. A is also positive. Now see, what will be this? We can use properties of limits here. That is limit A tends to 0. A tends to 0. By A, and by properties of limit we know that it will come out to be infinity. So it will come out to be infinity, which is also positive, Now we will apply properties of limit here. Now we will apply properties of limit here. Minus 12, 2A plus 12 by A, 15A, 2A plus 12 by A. When you will solve it, you will get minus 12. See, I am not going to teach you limits here. I expect that you must be knowing it. So after solving it, we will get minus 12. We will get minus 12. So this part, this part will be minus 12, which is less than 0, that is negative. This part is greater than 0. This part is greater than 0. So now if I will talk about the number of sign change, then positive, 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 negative. One sign change, negative to positive, two sign change. So sign change is, sign change is 2. So number of poles in RHS is equal to number of sign change. Poles in RHS is equal to number of sign change, that is 2. So poles in LHS. So poles in LHS is equal to 5 minus 2, 3. And what will be my system? My system will be unstable. What will be my system? My system will be unstable because we are having poles in RHS. Because we are having poles in RHS. So this was all about first special case of Routh criteria. This was all about the first special case of Routh criteria, and I hope that it is clear to you. Two important things which you should keep in mind, and that is this two thing. That is limit a tends to 0. That is a is tending to 0. A is tending to 0, and the sign of a and the sign of a and the sign of a is same as the first element of previous row. Sign of a is same as that of sign of first element of previous row. And then you have to just form Routh array. Use some basic properties of limit. Then find out the number of sign change. And you will get the desired result. Now coming to special case 2. Special case 2. So first we will write the statement and then we will look into it in details. This is very important for your exam point of view, and this is little complex also. So you have to be very attentive. You have to keep listening to each and every word of mine, and then it will become very simple to you. I am going to simplify this complex concept very well to you. So just keep listening to me and be attentive to each and every word. So first I will write the statement. So while forming Routh array, while forming Routh array, if all the elements in an odd row may result into 0, due to presence of poles, symmetrical about origin, due to which Routh array ends abruptly. Now To overcome this difficulty, to overcome this difficulty, replace the zeros, replace the zeros with the coefficient, with the coefficient of differentiated auxiliary polynomial, differentiated auxiliary polynomial, that is obtained, that is obtained from the row, from the row above the row of 0, above the row of 0. So this is the statement of special case 2. At a first look, and after listening to many technical words, uh, I know that you must not be having any idea that what is going about here, what I have written here, and what I mean to say from this statement. But don't worry, I will take each and every sentence, each and every technical words in details, and after solving questions, all these lines, all these words of this statement will be crystal clear to you. Now let us discuss this case through an example. I will take one or two example, and using those two examples I will discuss all the important conditions and probable questions and probable concepts and tricks of this special case, of this special case. So suppose we have a characteristic equation of this. Suppose we have a characteristic equation s4 plus s3 minus 3s square minus s plus 2. Now first we will form the Routh array. First we will form the Routh array. So let us form it. S4, S3, S2, S2, S1, S0. So coefficient of S4 will come here. Coefficient of S2 will come here. Coefficient of S0 will come here. Coefficient of S3 will come here. Coefficient of S will come here. It will be 0. Now we will try to find this one. This will be 1 into minus 3 minus 1 into minus 1. That is, it will come out to be minus 3 plus 1 by 1. That is, it will be minus 2. It will be minus 2. Now this one, this in 1 into 2, this 0 by 2, that it will come out to be 2. It will be 0. Now come in at S1 row. Now come in at S1 row. It will be minus 2 into minus 1. That is 2. Minus 1 into 2 by minus 2. That is, it will come out to be 0. And this into 0, this into 0, this will come out to be 0. And this will also be 0. So from here we can see that my complete S1 row is 0. So from here So from here we can see that my complete S1 row is 0. So from here we can see that my complete S1 row is 0. So now coming to our statement, while forming Routh array, all the elements in an odd row, this I will come into later. This I will come into later, but it is see. But let's see. All the elements in an odd row may result into 0. May result into 0. So we can see that our complete S1 row has resulted into 0. The concept of this odd row, this I will discuss little later. Leave this statement due to presence of poles symmetrical about origin. Uh, leave it for now. I will discuss it later. Coming to this, due to which Routh array ends abruptly. Now you can see that as my complete S1 row is 0, so my Routh array has ended abruptly. So my Routh array has ended abruptly. So now what we have to do to overcome this difficulty, replace the zeros with the coefficient of differentiated auxiliary polynomial that is obtained from the row above the row of 0. So coming to this part, that what is my auxiliary polynomial? What is my auxiliary polynomial? Auxiliary polynomial is obtained from the row above the row of 0. It is auxiliary polynomial. Auxiliary polynomial is obtained from the row above the row of zeros. From the row above the rows of 0. So, which row is above S1 row? S2 row is above S1 row. And from this S2 row, we have to find auxiliary polynomial. From this S2 row, we have to find auxiliary polynomial. So what will be my auxiliary equation? 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 My auxiliary equation will be, see how it is moving. It is S3, S2, S1, S0. So it will come out to be minus 2s square plus 2 is equal to 0. See how it is moving. This is S3. This is coefficient of S3. This is coefficient of S2. So this will be coefficient of S1. This will be coefficient of S0. So my auxiliary equation is this. My auxiliary equation is this. Now what we have to do with the auxiliary equation? We have to replace the zeros with the coefficient of differentiated auxiliary polynomial. That is, first we have to differentiate it. First we have to differentiate it. Suppose it is AE. Suppose it is AE. Suppose it is AE. Therefore, we have to find, or we can write it like this, or we can write it like this. Suppose it is AS. Suppose it is AS. We have to find DAS by DS. We have to differentiate it. What it will come out to be? It will come out to be minus 4s plus 0 is equal to 0 is equal to 0. Now see, coming to our statement, replace the zeros, that is, we have to replace the zeros of S1 row, we have to replace zeros of S1 row with the coefficient of differentiated auxiliary polynomial, So what are the coefficients of differentiated auxiliary polynomial? It is minus 4. That is, here we will get minus 4. Here we will get minus 4, because see how it is moving. This is S2, coefficient of S2. This is coefficient of S1. This will be coefficient of S0. This will be coefficient of S0. So it will come to be minus 4. No need to write 0 here because it is of no importance, but still we can write it 0, 0 here. But still we can write it 0, 0 here. Now after doing it, we have what we have to do. Now after doing this, we have to complete. Now after doing this, we have to complete our Routh array. We have to complete our Routh array. So see what will be coefficient of S0. It will be minus 4 into this, minus 2 into this by 4, that it will come out to be 2. It will come out to be 2. It will come out to be 2. So this is the process by which we have to form Routh array. In case my any entire row, in case my all the elements, in case all the elements of any row becomes 0, in case all the elements of any row becomes 0, in that case first we have to find auxiliary equation. First we have to find auxiliary equation. Auxiliary equation is found from the row which is just above the 0 row. It is found from above the row which is it is found from the row. It is found from the row which is just above the 0 row, which is just above the 0 row. After finding the auxiliary equation, we have to differentiate it. We have to differentiate it. Then the differentiated coefficient we have to put in the Routh array. Then the differentiated polynomial coefficients we have to put into the Routh array, and then we will complete our Routh table or array. And then we will complete our Routh table or array. Now coming to this odd row. Now coming to this odd row. See, it is not necessary. It is not necessary that always my odd row will become 0. It is not necessary that always my odd row will become 0, and corresponding to that my auxiliary equation will be formed only from the even rows. My auxiliary equation will be formed only from my even rows. It is not like that. It is not like that. My even rows can also become 0. My even rows can also become 0. And in that case, if my even row has become 0, then my auxiliary equation will be formed from the odd row. In that case, my auxiliary equation will be formed from the odd row. But see, it is not so important for your exam point of view. It is not so important for your exam point of view. In exam, you will generally get your odd row to be 0. You will generally get your odd row to be 0, and corresponding to that auxiliary equation will be formed from the even row only. So we will discuss this only in details. So we will discuss this only in details. So this was all about the forming of Routh array. Now see, coming to some other important properties and conditions. Coming to some important properties and conditions based on this case. Properties or conditions. Properties or conditions based on this special case. Based on this special case. First one is roots of auxiliary equation. Roots of auxiliary equation are also roots of characteristic equation. Are also roots of characteristic equation. That is, if you will find roots of this auxiliary equation, if you will find roots of this auxiliary equation, then those roots will also be the roots of this characteristic equation. Then those roots will also be the roots of this characteristic equation. Fine. This is the first property. This is the first property. Order of auxiliary equation. Order of auxiliary equation. Very important point. This is very important point. Order of auxiliary equation signifies number of roots or poles, which are symmetrical, which are symmetrical about origin, which are symmetrical, which are symmetrical about origin. Very important point. Listen to it carefully. Symmetrical about origin. Order of auxiliary equation signifies number of roots, poles, which are symmetrical about origin. Coming to our this example, what is the order of our auxiliary equation? What is the order of our auxiliary equation? Its order is 2. Its order is 2. That is, there are two roots or two poles which are located symmetrically about origin, which are located symmetrically about origin. Very important point. We will see it more. Things will get clear, but we are moving just step by step. Third, number of sign change. Number of sign change in first column. In first column of Routh array below auxiliary equation, below auxiliary equation signifies number of roots or poles. Very important point this also. In this case, all the points and all the sentences which I am saying is very important for building your concept and also for exam point of view. Roots and poles signifies numbers of roots and poles which are lying, which are lying, which are lying on right hand side of S plane, on right hand side of S plane, and they are also symmetrical about origin, and they are also symmetrical about origin, and they are also symmetrical about origin. Number of, see what I am saying, that number of sign change, number of sign change below auxiliary equation. See, this was our auxiliary equation. We will refer below it. Number of sign change, number of sign change below auxiliary equation, below auxiliary equation. See how many sign change are there? There is one sign change. Minus 2 is here, so minus 4 is here. Now plus 2 is there. One sign change. So one sign change, that is, it is signifying that there is one root or one pole on right hand side of S plane, on right hand side of S plane, and it is also symmetrical about origin. Very important. And it is also symmetrical about origin. Fine. Now coming to next point. Coming to next point. Number of sign change. Number of sign change. Number of sign change in first column of Routh array which are above auxiliary equation including auxiliary equation signifies number of roots or poles which are line on right hand side of S plane and they are not symmetrical about origin. Very important. See the difference between point number 3 and point number 4. In point number 3, we are referring the sign change below auxiliary equation. In point number 4, we are referring sign change above auxiliary equation, including this auxiliary equation row. In both the cases, the sign change represents the roots or poles lying on right hand side. But for the below case, it is also symmetrical about origin, but for the above case, it is not symmetrical about origin. Now see how we will find our result. From all these statements. Let us draw a S plane. This is my S plane. Now see, what is the order of auxiliary equation? The order of auxiliary equation is 2. That is, we are having two roots or two poles which are symmetrical about origin. Fine. Then we will look into the sign change in the first column of Routh array which are below this auxiliary equation. So there are one sign change, that is my one root will be lying on right hand side of S plane, but it is also symmetrical about origin. So for it to be symmetrical about origin, there has to be one pole in left hand side of S plane also. For suppose it is at +2. I am just supposing Routh Hurwitz criteria doesn't gives us the information that where the pole is lying, but just to give you the concept of symmetrical poles, I am taking that suppose it is at +2 and it is symmetrical about origin, then there has to be a pole at -2 in left hand side of S plane also. Fine, so let me delete it, otherwise you will get confused that Routh Hurwitz criteria gives us location of poles also. No, it is not like that. Now coming to the sign change above including this auxiliary equation row, then there is one sign change. It means that it is having that there is one more pole or root or at a right hand side of S plane, but it is not symmetrical about origin. So it is not symmetrical about origin, that is there will be no root or pole in left hand side of S plane corresponding to this root. So now see, we have got the location of three poles. Now see my characteristic equation. Is of order 4. That is there will be 4 roots. So I will put the fourth root or pole here. So I will put the fourth root of pole here. So if it is asked that poles on right hand side, answer will be 2. Poles on left hand side, answer will be 2. And my system is unstable. And my system is unstable. And my system is unstable. See, my characteristic equation is of order 4. That is, there are 4 poles. That is, there are 4 poles. Now coming to second one, my auxiliary equation is of order 2. That is, 2 poles are there which are symmetrical about origin. Now referring the lower part of this auxiliary equation row, I have found that there is one sign change. So there will be one pole at right hand side. Corresponding to that, there will be a symmetrical pole on left hand side also. Now referring the above portion, here we are having one sign change, that is there will be one pole at right hand side, but there will be no pole corresponding to this pole at left hand side. And now remaining we are having one pole, so that we will put into the left hand side. So I think many things are clear in this example. I will take one more example, so things will be more clear. Before taking next example, let us discuss some more important points in this example only. Let us discuss some more important points in this example only. Let me delete it because it will create confusion in your mind. Fine. So I told you that we have to refer all the elements of first column which are below this auxiliary equation row. So we referred here and we have to find out the number of sign change. So I told you here the number of sign change was 1, because here is -2, so here is -4, no sign change. -4 to 2, one sign change is taking place. And in second part, we have to refer all the elements of first column which are above the auxiliary equation row, including the auxiliary equation row, and we have to find the number of sign change. So here also we were getting one sign change. Now let us suppose that here we were not having -2, but here we were having +2. Suppose here we were having +2. Now see what will be the effect on the result. Now again we will first refer all the elements of first column which are below auxiliary equation row, and we have to find the number of sign change. Then see what will be the number of sign change. It is +2, it is -4. That is, we will get one sign change. -2 and 2, here we will get two sign change. Two sign change, that is, there are two roots on right hand side of S plane which are also symmetrical about origin. Now coming to the above portion, is there any sign change? No sign change. That is, there is no root in the right hand side of S plane, and which is not symmetrical about origin. In that case, what we would get? We will get the same result. But these two roots, in the previous one we told that these two roots are symmetrical about origin, but this and this are not symmetrical about origin. But in this case, these two roots would also have been symmetrical about origin. But in this case, these two roots would also be symmetrical about origin. That is, if it is at +2, it will be as -2. And if it is at +5, it will be at -5, because there are two sign change, that is two roots on right hand side which are also symmetrical about origin. So the remaining two roots we will get here only, but this and this are symmetrical and this are symmetrical. But in the previous question, not in the question, in the previous discussion, when it was not +2, it was -2, then also we were getting two roots here, two roots here, but these two roots were symmetrical, but this and these two roots were not symmetrical. So this is an important point which I wanted to include in this example only. Now coming to next example. So again, let us form the Routh, let us form the Routh array S6, S5, 4, 3, 2, 1, not. Here 1, 5, 2, -8. Here 1, 3, -4, 0. Here we will get this into this means here we will get 2. Here we will get this 6. Here we will get -8 and 0. Now here we will get 6, 6, 0. Here we will get -8 minus +8, 0, and this will be 0. So my S3 row is completely 0. My S3 row is completely 0. That is, it is special case 2. This question is a type of special case 2. So we have to apply all the concept based on it. We have to apply all the concept based on it. So first we have to find the auxiliary equation. First we will have to find the auxiliary equation from the row above S3. From the row above S3. So we will get 2S4 . This is S5, S4, S3, S2. 6S2, 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 S1, S0, -8. -8 is equal to 0. This is my auxiliary equation. This is my auxiliary equation. Now I will differentiate it. Now I will differentiate it. So I will get 8S cube 12s is equal to 0. Now this coefficients I will put in the Routh array. That is s cube, it will become 8. It will become 8 and 12 s. S4, S3, S2, S1. So 12 will come here. Here we can write 0, 0. Not much of significance. Now here what we will get? Here we will get 8 into 6, 48. 48, 6 are 48 minus 24 by 8. And here we will get 8 into -8 divide, that is we will get -8 here. -8 here. So it will come out to be, 3. It is -8. Now coming to this, it will be 12 into 3, 36 minus plus 64. It will be something 100 by 3. It will be 100 by 3. This will come out to be 0. Now it will come out to be -8. So now my Routh array is, or my Routh table is complete. Now my Routh table is complete. Now my Routh table is complete. Now we have to find the location of poles with respect to S-plane. Now we have to find the location of poles with respect to S-plane. So Our auxiliary equation is of order 4. Auxiliary equation is of order 4. That is, there are four roots which are symmetrical about origin. There are four roots which are symmetrical about origin. There are four roots which are symmetrical about origin. Now, let me draw a line here. Now we have to refer all the elements of first column which are below auxiliary equation row, and we have to find the number of sign change. We have to find the number of sign change. So see, positive here, positive here, positive here, positive here, negative here. We are having one sign change. We are having one sign change. That is, there is one root. That is, there is one root on right hand side and also symmetrical about origin. This result we have forgot. This result we have got by considering elements below this auxiliary equation row. Now we will consider all the elements of first column which are above auxiliary equation row, including auxiliary equation row, to find the number of sign change. This is positive, this is positive, this is positive. No sign change, no sign change. That is, there is no root, that is, there is no root on right hand side which are not symmetrical, which are not symmetrical about origin, Now let us draw the S plane. Let us draw the S plane and locate the poles, So what we have seen, we have seen that there are four poles which are symmetrical about origin. Fine. And there is one pole on right hand side. There is one pole at right hand side which is symmetrical about origin. That is, there will be one pole on left hand side also, and both these poles are symmetrical. That is, my characteristic equation is of order 6. So there are 6 poles. Out of these 6 poles, we have found the location of 2 poles. Now there are remaining 4 poles. Then see, my auxiliary equation is having order 4. That is, there are 4 poles which are symmetrical about origin. Out of those 4 poles, we have found 2 poles here. Then where will be the location of other 2 poles? See, very important. It is very important. Please listen it carefully. I told that auxiliary equation is of order 4. That is, there are 4 poles which are symmetrical about origin. Out of those 4 poles, we have found 2 poles which are symmetrical about origin. So where are my other 2 poles lying? Can I place it here? No, I cannot place it here because there is no pole other than this pole which is lying on right hand side and which is symmetrical about origin. So on right hand side we are having only one pole. So based on that pole, we have already drawn or located one pole which is symmetrical with it, which is symmetrical about origin. So my remaining 2 pole, there is only one option, and that is that we have to place it on imaginary axis. So for remaining 2 poles which are symmetrical about origin, we have only one option, and that is to place it on the imaginary axis. Now see, these 2 poles are also symmetrical about origin. So now this condition that is auxiliary equation of order 4 having 4 poles symmetrical about origin. We have found all the 4 poles. We have found the location of all the 4 poles. But my characteristic equation is of order 6. So there must be another 2 poles which is lying. So where I will put this 2 poles? Can I put it on right hand side? No, because on right hand side there will be only one pole, because there is only one sign change. Can I put it into imaginary axis? No, I cannot put it on imaginary axis. So we have to put it on LHS. 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 So now my final conclusion, poles on RHS, poles on RHS 1, poles on LHS 3, poles on imaginary axis 2. Is my system stable, unstable? My system is unstable. My system is unstable. I hope now you have got this concept. I hope that now you have got this concept after solving these two questions. I hope that now you have got the concept that how we have to apply the concept of symmetrical poles. How we have to apply the concept of symmetrical poles, and when poles will lie on the imaginary axis, and when poles will lie on the imaginary axis, and when poles will lie on the imaginary axis. Now suppose let us take one more condition in this example only. Let us take one more condition in this example only. Suppose it is not -8, it is +8. Suppose this is not -8, it is +8. Suppose this is not -8, it is +8. I am deleting it. I hope that you have copied it. Now see the fun. So now again, characteristic equation is of order 6. There will be 6 poles which we have to find. Auxiliary equation is of order 4. That is, there are 4 poles which are lines symmetrical about origin. Now we have to check number of sign change below. Are we getting any sign change? No. That is, there are no poles on right hand side which is symmetrical about origin. Now we have to check the upper part. Is there any sign change? No. That is, there is no pole on right hand side which is not symmetrical about origin. Then where are the poles located? Then where are the poles located? Let us draw the S plane. No sign change, no sign change. That is, obviously we know that no poles are lying on right hand side, because for poles lying on right hand side there has to be a sign change. There is no sign change, so we can say that there is no pole lying on right hand side. But there are 4 poles, because the order of auxiliary equation is 4. So there are 4 poles which are symmetrical about origin. Symmetrical about origin. So where we can place it? Can we place these 2 poles here? Can we place these 2 poles here and 2 poles here? No. Why? Because there is no sign change. So there will be no poles on right hand side. So the only place where we can put these poles are on the imaginary axis. On the imaginary axis. My 4 poles will be on imaginary axis, and they are symmetrical with each other. And they are symmetrical with origin. Not with each other, but they are symmetrical. But they are symmetrical with origin. With respect to origin. Now where will be my remaining 2 poles? Put it on LHS. Put it on LHS. Now see my conclusion. Poles on RHS. Pole on RHS 0. Poles on LHS 2. Poles on imaginary axis 4. Now say, is my system stable or unstable? My system is neither stable nor unstable. My system is marginally stable. My system is marginally stable. My system is marginally stable. Because there is no poles on right hand side, so I cannot say that my system is stable. And it is also not that all my poles are on left hand side, and it is also not that all my poles are on left hand side. My four poles are on imaginary axis, and we have discussed this earlier also, that if my poles are on imaginary axis, then my system will be marginally stable. Then my system will be marginally stable. Then my system will be marginally stable. I hope this is now fully clear to you. I hope this is now fully clear to you. Now I will take one more concept based on this special case, and then it will be over. I will take one more concept of repeated roots, which is also based on this special case, and then this special case 2 will be completed. Now, coming to another important concept, which is based on our special case 2. Now, coming to another important concept, which is also based on our special case 2, and that is, if more than one rows becomes completely zero, then what will be the result? That is, if more than if more than one row if more than one row of Routh array becomes completely zero becomes completely zero becomes completely zero, then what will be the outcome? So first, we will form the Routh array from the given characteristic equation. First, we will form the Routh array from the given characteristic equation, and then we will discuss results one by one. This is also very important for your exam, or you can say for objective point of view. This concept is very important. In ESE objective, or in PSU objective, or in assertion reason questions, questions based on such concepts are very frequent, in which if the concept is not clear, then you will make mistakes. So you will make a mistake. So be attentive here. We will get 4 here, 2 here. Now 1 here, 2 here, 1 here. 1 2 1 2 4 2 2 4 2 2 4 2 1 2 1. Now coming to here, what will be this? This will be my 0. What will be this? This will be 0. This is 0. That is one entire row. S3 row is 0. S3 row is 0. So what we have to do? We have to form auxiliary equation. So we will get S4 to S2 plus 1 is equal to 0. Then we will differentiate this auxiliary equation. We will get 4s3 plus 4s is equal to 0. Now we will put this coefficients of auxiliary equation in our Routh array. We will put coefficients of auxiliary equation in Routh array. We will get something like this. Now again we will continue forming our Routh array. Now it will be 8 4 4 1. It will be 4. It will be 1. It will be 0. Now this will be again 0 0. That is, now again my S1 row has become 0. S1 complete, S1 row has become 0. So again we will form auxiliary equation. So again we will form auxiliary equation. So it will be S square S3, S2, S1, S0 plus 1 is equal to 0. Now we will again differentiate it. Now we will again differentiate it and we will get 2s is equal to 0. Now we will put this coefficient in the Routh array. We will put this coefficient in the Routh array and then we will continue. And then we will continue our Routh array. It will be this, that is, it will be 1. 1 will come here. 1 will come here. 1 will come here. So now see, now we are having two rows, S3 row which is completely 0 and S1 row which is completely 0. Now see what will happen. Now see what will happen and what result we will get. What result we will get. Now come in here. Now come in here. What will be my auxiliary equation? What will be my auxiliary equation for this S1 row? My auxiliary equation is S square plus 1 is equal to 0. Fine. What will be my roots of this auxiliary equation? It will be S is equal to plus minus J. It is S is equal to plus minus J. Fine. Now come into this auxiliary equation. Come into this auxiliary equation. We will get S4 plus 2S square plus 1 is equal to 0. If I try to solve it, what we will get? We will get S square plus 1 whole square is equal to 0. So if I try to find the roots, what we will get? What we will get? We will get S is equal to plus minus J and plus minus J and plus minus J. S is equal to plus minus J and S is equal to plus minus J. See, here I am going to give you a important, now let me write this properties only. Let me write this is properties only, point wise only, so that it will be easy for you to remember. First one, roots of this roots of this auxiliary equation. Roots of this auxiliary equation, that is roots of this auxiliary equation, will be also the roots of this auxiliary equation, will be also roots of this auxiliary equation. And it is similar that we discussed earlier also, that roots of auxiliary equation are also the roots of characteristic equation, are also the roots of characteristic equation. So roots of this auxiliary equation will be will also be roots of this auxiliary equation, and roots of both this auxiliary equation will also be roots of characteristic equation, and roots of these two auxiliary equation will also be roots of characteristic equation. So we can write it like this: roots of lower auxiliary equation will also be roots of upper auxiliary equation. Upper auxiliary equation. Fine. Now coming to this auxiliary equation, we have found the roots. And we have seen that the roots are at plus minus j, and its root was also plus minus j, and it is also part of this, and this is also part of this, this is also part of this. That is, we can conclude one more very important point here, that we get repeated roots on imaginary axis. We get repeated roots on imaginary axis when more than one row is zero in Routh array. That is, we get repeated roots on imaginary axis when more than one row is zero in Routh array. So from this we can conclude very important thing that we have seen in time domain analysis also, that if there are repeated roots on imaginary axis, then my system is unstable. That is, if we have repeated roots on imaginary axis, then my system is unstable. That is, when there are more than one zero row in Routh array, then our system will be unstable. Then our system will be unstable. When there are more than one zero row in Routh array, then our system will be unstable. Very important points. These points are very important. That is, if we get repeated roots on imaginary axis, when more than one row is zero in Routh array, and when they are repeated roots on imaginary axis, then my system will be unstable. This we have discussed in time domain analysis also. Now, where will be my location of roots? Here, my location of roots are at plus minus j, one here, and here again plus minus j, that is, we are getting repeated roots at plus minus j. Here we are getting two roots at plus minus j, because there are two rows which are completely zero. Suppose if there were three rows which were completely zero, then we would have got three repeated roots on plus minus j. Here we were having two roots. Here we were having two rows which are completely zero. That is, that's why we were having two repeated roots on plus minus j. But suppose if there were three rows which were completely zero, then we would have got three roots on imaginary axis, three repeated roots on imaginary axis at same position, at same location, and because of this my system will be unstable. So this was all the concepts based on special condition 2. Please go through all the concepts once again. Try to solve questions on this. Anyway, I have given 4 to 5 questions on this, some directly, some indirectly. So I think that from question point of view, it is sufficient. But you just have to know the concepts. And you have to know the important points which are related with this special condition 2. So till now, what we have studied is that if there is no sign change in first column of Routh array, then all the poles of characteristic equation will lie on the left hand side of S plane, and my system will be stable. Then we studied that if there is a sign change in the first column of Routh array, then the number of sign change indicates the number of roots which are going to lie on the right hand side of the S plane, and my system will be unstable. Then from the special case 2, we studied that if an entire row of Routh array is 0, if the entire row of Routh array is 0, then there are two possibility. Either my system will be marginally stable, that is, the roots will lie on the imaginary axis and they will be symmetrical about origin. Roots will lie on the imaginary axis and they will be symmetrical with respect to origin, or my system will be unstable, that is, my roots will lie on the right hand side of S plane. It will lie on the right hand side of S plane and symmetrical about origin. In this case, there is also possibility that some roots may lie on the imaginary axis and they are also symmetrical about origin. So if an entire row of Routh array becomes 0, then it is sure that my system will never be stable. It will be either marginally stable or it will be unstable. Fine. Now, if my system is marginally stable, then we have learned it in time domain analysis also. That is, if my system is marginally stable, that is, if we are having roots on imaginary axis, then we call this system as undamped system. And this undamped system has natural frequency of oscillation omega n, and this undamped system has natural frequency of oscillation natural frequency of oscillation that is omega n. Undamped, that is, it is having natural frequency of oscillation, that is omega n. Fine. Now we will move to our next topic. That is conditional stability. That is conditional stability. So what is this conditional stability? When system is stable, under certain conditions, under certain conditions, when system is stable under certain conditions, then it is said to be conditionally stable. So what is conditional stability? We have learned stable, unstable, marginal stable. Now we are looking into conditional stability. So when system is stable under certain conditions, when system is stable under certain conditions, then it is said to be conditionally stable. That is, system is not always stable. That is, system is not always stable. There are certain conditions for which system will be stable. There are certain conditions for which system may be unstable, and there are certain conditions for which system may be marginally stable. Then such a scenario is said to be conditional stable. Then such a scenario is said to be conditional stability. Then such a scenario is said to be conditional stability. Now, what are these certain conditions? These certain conditions may depend upon certain parameters of system. These certain conditions may depend upon certain parameters. These certain conditions may depend upon certain parameters of system. That is, for example, it may depend upon the gain of the system. For example, it may depend upon the gain of the system. It may depend upon the gain of the system. It may depend upon the gain of the system. That is, there may be certain value of gain. There may be certain value of gain for which system will be stable. There may be certain value of gain for which system may be unstable, and there may be certain value of gain for which system will be marginally stable. Then this scenario is said to be conditional stability, or my system is said to be conditionally stable. So let us take some examples. Some examples to find out how this conditional stability works. How this conditional stability works. Now let us take an example. Here, characteristic equation is given S4 plus 5S3, 5S square, 4S plus K is equal to 0. What are asked from us? To find range of K. To find range of K for system to be stable. Find maximum value of K for system to be stable. Calculate frequency of natural oscillation. Calculate frequency of natural oscillation. So first solve this exam. So first I will solve this example. So first I will start solving this example, and during the course I will give you some important concepts regarding questions which are based on this concept of conditional stability. This is a very favorite area for GATE exam. You will see in your previous papers that there are many questions in all the branches based on conditional stability, and this type of questions are very easy, very scoring. You have to get full marks out of it because it is very easy. After solving this one or two questions, you will see that how easy questions are based on this concept. So let us see. So my characteristic equation is S4, 5S3, 5S2, 4S plus K. 4S plus K. K is the system gain. K is the system gain. So first we will form a Routh array. First we will form Routh array. First we will form Routh array. So the first we will find the coefficient of S4 1, then alternate 5 will come, then k will come. Here 5 will come, then 4 will come, and here 0. This we will get as 25 minus 4, that is 21 by 5. This we will get something like 5k minus this by 5, that is we will get 5k. Then this we will get 84, 84 by 5, 84 by 5 minus 25k, minus 25k by 21 by 5, by 21 by 5, and this part we will get 0. Now S0 we will get 5k. Now S0 we will get 5k. Let this be 0, 0. So now see, we very well know that for system to be stable, all the elements of a first column of Routh array must have same sign. All the elements of first column of Routh array must have same sign. So it is positive, it is positive, it is positive. So for making this system stable, we have to make this one positive and this one positive. So what we will do? We will equate it. We will equate 84 by 5 minus 25 by k by 21 by 5 greater than 0. Why we are putting greater than 0? Because we want to make this coefficient positive, because all the coefficients are positive. So for this system to be stable, this has to be positive, this coefficient has to be positive, and this coefficient also has to be positive. So this will be my equation 1, and this 5k is greater than 0. This will be my equation 2. So from this two equation, we will find value of k. From this two equation, we will find value of k. So from this, what we will get? We will get something like this: 84 by 5 greater than 25k. That is, k is less than 84 by 125. 84 by 125. Put it as equation 3. From this, we will get k is greater than 0. K is greater than 0. Then see, coming back to our question, find range of k for system to be stable. Find range of k for system to be stable. So for system to be stable, what will be my range of k? See, my range of k will be, k should be greater than 0, which we are getting it from equation 4. K should be greater than 0, and it should be less than 84 by 125. It should be less than 84 by 125. See, will this be my range of k? Will this be my range of k for system to be stable? Yes, this will be my range of k for system to be stable, because if range of k is within this, that is, if k is within this range, if it is greater than 0 and less than 84 by 125, then all the elements of first column, then all the elements of first column, then all the elements of first column will be positive. That is, there will be no sign change, and so all the roots will be lying on the left hand side of S plane. It will be lying on left hand side of S plane. Fine. Now coming to the second question, find maximum value of k for system to be stable. Find maximum value of k for system to be stable. See, here I have done a minor mistake here. Here I have done a minor mistake. I have written 5k, but it will not be 5k because it will be 5k minus 1 into 0 by 5. So it will be 5. So it will be 5. It will not be 5k. Please correct it. It will be only k. It will be only k. So here we will get, it will be same. It will not be 25k. It will be 5k. It will be 5k, and then it will be 5k, and here also we will get only k. Here also we will get only k. So we have to do these changes here also. It will be 5k, 5k, it will be k, it will be 5k. So it will come out to be k will be less than 84 by 25. K will be less than 84 by 25, and this is okay, and this one is okay. This one is okay. So the range of k will be, k should be greater than 0, k should be greater than 0, k should be greater than 0, and less than 84 by 25. K should be greater than 0 and less than 84 by 25. Fine. So now coming to our next question, find maximum value of k for system to be stable. So what will be my maximum value of k? Here we can see that my k max, that is my k max will be equal to 84 by 25. My k max will be equal to 84 by 25. My k max will be equal to 84 by 25. Fine. Now coming to the third part, calculate frequency of natural oscillation. Calculate frequency of natural oscillation. Now coming to this slide, I told you that when we will get a natural frequency of oscillation Wn, when we will talk about natural frequency of oscillation Wn, we will talk about natural frequency of oscillation Wn when my system is undamped. When my system is undamped. When will be my system undamped? When will be my system undamped? It will be undamped when my system is marginally stable. When my system is marginally stable. When my system will be marginally stable. When the roots are on imaginary axis. When the roots are on imaginary axis. When will be my roots on imaginary axis? When one entire row of Routh array has become 0. When one entire row of Routh array has become 0. When one entire row of Routh array has become 0. When one entire row of Routh array has become 0. So coming back to our Routh array, here which row I will make 0? I will make S1 row to be 0. I will make S1 row to be 0. I will make S1 row to be 0. If I will make S1 row 0, that is I will get 84 by 5, 84 by 5 minus 5k by 21 by 5 by 21 by 5. This I will put it as 0. After putting it as 0, what value we will get of k? K we will get as 84 by 25. K we will get as 84 by 25, which is nothing but k max. Which is nothing but k max. Fine. Now, to find frequency of natural oscillation, we have to refer the auxiliary equation. We have to refer the auxiliary equation, and in auxiliary equation we have to put value of k. We have to refer auxiliary equation. We have to refer auxiliary equation. We have to refer auxiliary equation, and in auxiliary equation we have to put value of k. And in auxiliary equation, we have to put value of k. So what will be my auxiliary equation? It will be 21 by 5 s square. It will be 21 by 5 s square plus k is equal to 0. This is my auxiliary equation. Now put in value of k here. Now put in value of k here. We will get 84 by 25 is equal to 0. So s square will be minus 84 by 25 into 5 by 21. That is 4 minus 4 by 5. Minus 4 by 5. So s will be plus minus j root 4 by 5. So s will be plus minus j root 4 by 5. Now s we can write it as j omega n. J omega n is equal to plus minus j root 4 by 5. Root 4 by 5. That is omega n. Omega n will be root 4 by 5. Omega n will be root 4 by 5. This is my answer to frequency of natural oscillation. That is omega n. Value of omega n will be equal to root 4 by 5. Now if it is asked to find the location of poles on the imaginary axis, if it is asked to find the position of poles on imaginary axis, then it will be my plus j omega n, and it will be my minus j omega n. That is, this will be my plus j root 4 by 5 and minus j root 4 by 5. And this is what we are getting it from here, or we can say that this is what we are getting it from here. Now see, now coming to another interesting part. That is, the range of k for system to be stable was this. That is, range of k for system, range of k for system to be stable, range of k for system to be stable is k is greater than 0, and k is less than 84 by 25. It is less than 84 by 25. Now suppose value of k is less than 0. Value of k is less than 0, or value of k is greater than 84 by 25. So what will be impact on my system? My system will become unstable. You can take any value. You can take any value of k which is less than 0. You can put it here. or you can take any value of k greater than 84 by 25. You can put it here, you can put it here. You will see that there will be sign change. You will see that there will be sign change. That is, my system will become unstable. Fine. Now suppose my value of k is either 0 or my value of k is 84 by 25. My value of k is either 0 or it is a k is equal to 84 by 25. Then what will be impact on my system? What will be impact on my system? My system will become marginal stable. My system will become marginal stable. My system will become marginal stable. This we have seen here also. This we have seen here also, that when my value of k was 84 by 25, then my entire row, then entire this row became 0, and when entire row becomes 0, then my system becomes marginal stable, or it may become unstable depending upon the sign change, depending upon the sign change. Similarly, if we will put k is equal to 0 here, similarly, if we will put k is equal to 0 here, then my entire this row will become 0, then my entire this row will become 0, and my system will become marginal stable. That is, if I will put value of k is equal to 84 by 25, if I will put value of k is equal to 84 by 25 here and here, then my system will become marginal stable, because my entire row will become 0. Entire row will become 0, and this we have seen here also. By putting the value of k 84 by 25, we have found the frequency of natural oscillation. And my system will not be unstable. My system will not be unstable because there will be no sign change. Similarly, if I will put value of k is equal to 0 here and here, then my this row will become 0, and again my system will become marginal stable, but it will not become unstable because there will be no sign change. So these are some very important concepts. So these are some very important concepts based on the conditional stability of a system, based on conditional stability of a system, and based on this questions based on this concept is frequently asked in exam. Questions based on this concept is frequently asked in exam. You will be given a characteristic equation. First, you will be asked to find range of k. First, you will be asked to find the range of k. That we can easily find, considering that we have to make all the elements of first column of Routh array to be positive, or to be positive. Then we can find the range of k. We can find the range of k. Then they will be asked to, then they will ask to find the maximum value of k. Maximum value of k can also be found from the range only. And then it will be asked to find the frequency of natural oscillation. It will be asked to find the frequency of natural oscillation. For that we have to make one entire row 0. But for that we have to make one entire row 0. And for making one entire row 0, what will be my value of k? What will be my maximum value of k? We will not take minimum value of k here. We will not take minimum value of k here. We will take maximum value of k here, and then we will put this maximum value of k into the auxiliary equation, and then we will find the frequency of oscillation Wn. In this we can add one more thing, that if it is asked to find the location of poles on the imaginary axis, then that also we can find it from here. Then also that we can find it from here. Now we can get one more thing, that the range of k for system to be stable we have found out. If it is asked to find the range of k for system to be unstable, then we can use this range only, and we can find the range for system to be unstable, all the values of k for system to be unstable. And if we are asked to find the value of k for system to be marginal stable, then also we can use this equation also. Then also we can use this range also. So this was all the concepts based on conditional stability. questions based on these concepts are very simple. You will get it in this form only, so I am not going to solve many another questions based on this concept. You can do it on your own, taking the previous year exam paper. Otherwise, you can refer my capsule questions booklet. Otherwise, you can refer my capsule questions booklet. There I have put a number of questions based on this concept. There I have put a number of questions based on this concept. Now, coming to next concept, and that is relative stability. Now, coming to the concept of relative stability. So earlier also we have discussed a little bit about absolute and stability. Fine. So earlier also we have discussed a little bit about absolute and relative stability. So in a layman language, if anyone asks you that tell me the difference between absolute and relative stability, then you will say it in this way, that suppose there are 10 students. That is, suppose there are 10 students, and if it is asked to there, suppose there are 10 students and exam is conducted and results are announced, so after announcement of result, if anyone asks the school administration that you give me a data of how many students have passed and how many students have failed, then suppose 4 students have passed and 6 students have failed, then the school administration will submit a report that 4 students passed and 6 students failed. 4 students passed and 6 students failed. This description is said to be absolute stability. This description is said to be absolute stability. And in Routh Hurwitz criteria, we are determining absolute stability only, because if there are 6 poles, then we can find out from Routh Hurwitz criteria or from Routh table that how many poles are on the left hand side of S plane and how many poles are on right hand side of S plane, and this is nothing but absolute stability. Routh array is not giving us the information about the location of roots. Routh array is not giving us the information about location of roots, and Routh array is also not giving us the information that which pole or which system is more stable with respect to another system or another pole. And it is also not giving us the information that which pole or which system is more stable with respect to another pole or system. So now after this, if we come to relative stability, then we can as a layman we can say it in this term, that suppose again the school administration is asked to submit a report, and this time in report the school administration has to properly define the rank of these 10 students. Now the school administration has to submit rank of each student. Then the students will be categorized in serial number 1 to 10. relative with respect to their mark, with respect to the marks which they have obtained in exam, with respect to the marks which they have obtained in exam. This is nothing but relative stability. This is nothing but relative stability. One student is judged. One student is judged or categorized with respect to or with relative to another student, with relative to another student. So this is the difference between absolute stability and relative stability in a layman language. In a layman language, I told you that from Routh array, we can easily find absolute stability. But from Routh array, can we find relative stability? Then the answer is yes. From Routh array, we can also find relative stability. But for relative stability, Routh array is not preferred because the time taken for finding the relative stability is very much. Lot of time will be taken or lot of time will be wasted to find relative stability with the help of Routh criteria. And in frequency domain, we are having better tools or better techniques of finding relative stability. So even if Routh array or Routh Hurwitz criteria can give us relative stability, but we do not deploy it because it is a very time consuming process. So Routh array is perfect for only absolute stability. Now I will show you that using Routh Hurwitz criteria, how we can determine relative stability. How we can determine relative stability. Suppose this is any reference plane. Suppose this is any reference plane. Say it is our S plane only. Say it is our S plane only. Here we are having two poles. Here we are having two poles at -2 and -3. Suppose this is our two poles. Now from Routh array, how we can find the relative stability? From Routh array, how we can find relative stability? First, we will form Routh array considering imaginary axis. Considering imaginary axis to be at s is equal to 0. Considering imaginary axis at s is equal to 0, we will form Routh array. And if we will form Routh array, then we will get the result that our system is stable because both roots will be our line, because both roots are lying on LHS of S plane. Now what we will do? Now we will shift this imaginary axis. Suppose now it is shifted. Now suppose it is 0.5. Now suppose imaginary axis is shifted at s is equal to 0.5. Now suppose imaginary axis is shifted at s equal to 0.5. Now again we will form Routh array considering imaginary axis to be at s is equal to 0.5. How we will form Routh array, that I will take with an example. So don't go into the calculation part. Now you just listen the technique that how relative stability is calculated or found out using Routh array. So now we will form Routh array considering imaginary axis at s is equal to 0.5. So again our system will be stable because both roots are lying on LHS. In this way, I will keep on shifting my imaginary axis. And a time will come when my imaginary axis will be at s is equal to -2. Now I will again form Routh array, and this time my system will be marginally stable as one pole is lying on the imaginary axis. So fine. Now again I will shift imaginary axis. I will keep on shifting imaginary axis, and suppose imaginary axis is now at s is equal to minus 2.5. S is equal to minus 2.5. Now again I will form Routh array. And this time my system will become unstable, because we will have one pole lying on LHS of this imaginary axis, or at LHS of S plane, where imaginary axis is at s is equal to minus 2.5. So here we can also conclude that the relative stability of this pole or this system, that is minus 2, is less as compared to the relative stability of this pole at minus 3, or this system as minus 3. So this is the way how we can find the relative stability using Routh array, and you can see that how much time it will take for us in determining relative stability, whereas in frequency domain we have very best technique which will give us the result in shortest possible time. That's why Routh array is preferred only for absolute stability and not for relative stability. Now let's take an example that how this shifting of S-plane is done, and based on that how we can find Routh array and finally our result. Suppose, let us take an example. Suppose open loop transfer function is given as k by s plus 2. Find value of k. Find value of k for closed loop pole. Find value of k for closed loop pole to be on left of s is equal to minus 5 line, or s plus 5 is equal to 0. Closed loop transfer function is given. We have to find value of k for closed loop pole to be on left of s is equal to minus 5 line. That is now my imaginary line or my reference line, has shifted. Imaginary line or my reference line has now shifted at s is equal to minus 5, and now we have to determine location of poles with respect to this reference line, and then only we can conclude about the stability of system. So see how we will solve such questions. So my characteristic equation is k by s plus 2, 1 plus k by s plus 2 is equal to 0. That is s plus 2 plus s plus 2 plus k is equal to 0. S plus 2 plus k is equal to 0. S plus 2 plus k is equal to 0. Now the reference line is given at s equal to minus 5. Reference line is given at s is equal to minus 5. So we will write reference line is s is equal to minus 5. We let us consider s plus 5 is equal to z. S plus 5 is equal to z. Z is a new reference plane. Z is a new reference plane. Z is a new reference plane. Suppose we are considering that Z is a new reference plane and Z is equal to S plus 5 and Z is equal to S plus 5. Therefore, S will be Z minus 5. Therefore, S will be Z minus 5. What we have done? First, we have found the characteristic equation. This is my characteristic equation. Reference line given is S is equal to minus 5. So, we have considered S plus 5 is equal to Z. Z is a new reference plane. Z is a new reference plane. So, S is equal to Z minus 5. So S is equal to Z minus 5. So S is equal to Z minus 5. So S is equal to Z minus 5. Now we will put the value of S. Now we will put the value of S in our characteristic equation. Now we will put the value of S in our characteristic equation. Now we will put our value of S in our characteristic equation. So we will get something like this. Z minus 5 plus 2 plus k is equal to 0. That is Z plus k minus 3. Z plus k minus 3 is equal to 0. Now we will form Routh array. Now we will form Routh array. This is my new characteristic equation. This is my new characteristic equation. Now we will form Routh array. So it will be Z1. It will be Z0. Z1 is 1. Z0 is k minus 3. Now what we are asked to find? We are asked to find value of k for closed loop pole. For closed loop pole to be on left of S is equal to minus 5 line. That is, for the poles to be lying on the left hand side of S is equal to minus 5 line. For the poles to be lying on the left hand side of S is equal to minus 5 line, all the elements of first column of Routh array has to be positive. All the elements of first column of Routh array, all the elements of first column of Routh array has to be positive. This is obviously positive. This is obviously positive. So this will be also positive. This is obviously positive. This is obviously positive. So this is obviously positive. So for this to be positive, value of k will be greater than 3. So for this to be positive, so for this to be positive, so for this to be positive, value of k has to be greater than 3. So this is my answer. So this is my answer. So these are the type of questions. These are the type of questions which may be asked by changing the reference line. By changing the reference line. So you have to follow this method. So you have to follow this method, and you can easily get the result. You can easily get the result. You can easily get the result. Now coming to the last topic. Now coming to the last topic of Routh Hurwitz criteria, and that is limitation. And that is limitation of Routh Hurwitz technique. Limitation of Routh Hurwitz technique. Limitation of Routh Hurwitz technique. So first limitation is Routh Hurwitz is a simple Routh Hurwitz is a simple Routh Hurwitz is a simple statistical technique which determine closed loop stability, which determine closed loop stability in a very limited manner, in a very limited manner. Routh Hurwitz is a simple statistical technique which determines closed loop stability in a very limited manner. Routh Hurwitz is used to determine absolute stability in which we cannot find actual root which is causing instability. Routh Hurwitz is used to determine absolute stability in which we cannot find actual root which is causing instability. Routh Hurwitz is not preferred. Routh Hurwitz is not preferred for determining relative stability. This part we have already discussed. For determining stability, Routh Hurwitz uses characteristic equation as opposed to other technique which can determine stability from open loop transfer function only. That is in Routh Hurwitz we are using characteristic equation, that is we are using closed loop transfer function. But in other techniques that we will look into, that is root locus, Bode plot and Nyquist plot, we can determine stability from open loop transfer function only. Next limitation is it is not possible to form Routh array if coefficient of characteristic equation are complex or if transfer function consists of infinite series, or if transfer function consists of infinite series, that is exponential function, or sinusoidal function, This exponential function we can also say as a transportation lag. transportation lag. Transportation lag. So it is not possible to form Routh array if coefficient of characteristic equation are complex, or if transfer function consists of infinite series like exponential function or sinusoidal function. That is, suppose if we are given an open loop transfer function in the form of this e to the power minus st, e to the power minus st by s plus 1, s plus 2. So for this open loop transfer function, we cannot find a Routh array. We cannot find a Routh array because it is in the form of exponential function. Because it is in a form of exponential function. So to perform Routh array, we have to equate this. We have to equate this as 1 minus st using Taylor series concept. Using Taylor series concept. We have to equate e to the power minus st. We have to equate e to the power minus st is equal to 1 minus st, e to the power minus st, e to the power minus st, 1 minus st, 1 minus st, 1 minus st, 1 minus st. So now we can say that open loop transfer function is 1 minus st, 1 minus st by s plus 1 by s plus 2. So my characteristic equation will be 1 plus 1 minus st by s plus 1 s plus 2. So it will come out to be s plus 1 s plus 2 plus 1 minus st is equal to 0. This is my characteristic equation, and now we can form Routh array and determine stability. I am not going to form it, but because from here you can continue on your own. But I am just showing you that if you get a question based on this concept, then how you can form the Routh array. If you get a question based on this concept, then how you can form the Routh array. So these are all the limitations. So these are all the limitations of Routh array. So this was all about Routh Hurwitz criteria. So this was all about Routh Hurwitz. So this was all about Routh Hurwitz criteria. Now we will start the next chapter. Now we will start the next chapter, that is root locus. That is root locus. Now let's take one more example. Suppose characteristic equation is given like A3S3, A2S2, A1S1, A0 is equal to 0. And we are asked to determine its stability. And we are asked to determine its stability. So we will apply Routh Hurwitz criteria. So we will apply Routh Hurwitz criteria, and we will get something like this: S3, S2, S1, S0. Here A3 will come, then alternate A1 will come. Here A2 will come, then alternate A0 will come. Now what will come at S1 row? It will come A2, A1 minus A0, A3, A0, A3 by A2. Here we will get 0 because here and here we are having 0, 0. What will come here? It will come this into this minus this into this by this. That is here A naught will come. Now we have to check first column of Routh Hurwitz table. Now we have to check first column of Routh Hurwitz table. Now we can say that suppose if A3 is positive, A2 is positive. Let us consider A3 is positive. See, here I am going to give you a very nice shortcut for checking the stability without actually forming the Routh array. So listen it carefully. So suppose if A3 is positive, A2 is positive, suppose A0 is also positive. Now, for this system to be stable, all the elements of first column of Routh table has to be must have same sign, and now as we have considered A3 to be positive, A2 to be positive and A0 to be positive, so now if our this term is also positive, if our this term is also positive, then we can say that my this system is stable. Then we can say that my this system is stable. That is what we will get. We will get A2 A1 minus A0 A3 if it is greater than 0. If it is greater than 0, because A2 will come this side, so it will be obviously 0. So if A2 A1 minus A0 A3 is greater than 0, then all the elements of first column of Routh array will be having same sign, that is all are positive. So my this system will be stable. See, what is this? What is A2 minus A1? A2 minus A1. If I call it as a inner product, if I call it as a inner product, and what is this A0 A3? A3 A0. A2 A1 inner product, and what is this A0 A3? Suppose I call it as outer product. Suppose I call this term as outer product. So now see, if my inner product, is greater than outer product, if my inner product is greater than outer product, then I can say that my this term will be positive, and so all the elements of first column of Routh array will be positive, and my system will be stable, So I suppose this is clear. If this is clear, then I will give you a short trick. See, what is this short trick? Short trick for concluding, stability for third order polynomial. This is important. For third order polynomial, this trick is applicable only for third order polynomial. Polynomial with all coefficients positive. This is another important and necessary condition for applying this short trick with all coefficient positive. Without without actually finding without actually finding Routh array. Routh array. Now see. So suppose we are given a third order polynomial. Suppose we are given a third order polynomial and all the coefficients are positive and all the coefficients are positive. These two conditions are necessary conditions for applying this short trick. Keep in mind, don't do blunders in exam. These two conditions are necessary condition. First, that is, you must be having a third order polynomial. Characteristic equation must be a third order polynomial and all coefficients must be positive. If all coefficients are negative, then also you cannot apply this short trick. If all the coefficients are combination of positive and negative, then also you cannot apply this short trick. This short trick can be applied only when all coefficients are positive. In that case, without forming Routh array, we can comment on the stability. We can comment on the stability by just finding the inner product and outer product. By just finding the inner product and outer product. By just finding inner product or outer product. This short trick will be very useful for ESE pre-exam and for PSU exams because there the time limit is very crunch. So you should know this type of short trick which will help you in saving 1 or 2 minutes in exam, which becomes very crucial uh, for competition point of view. So suppose let take example 1. Suppose we are given a characteristic equation which is a third order polynomial 2s2 3s1 5 is equal to 0. So first of all we will find inner product. First of all we will find inner product. Inner product is inner product is 6. Then we will find outer product. Then we will find outer product. Outer product is 5. So now my inner product. So now my inner product. So now my inner product is greater than outer product. So my system is stable. So my system. So my system is stable. My system is stable. Whenever inner product is greater than outer product for third order polynomial with all coefficients having positive sign, then my system will be stable. Then my system will be stable. Proof we have seen here. Proof we have seen in this slide. So now coming to next example. Coming to next example. Suppose characteristic equation given is third order polynomial Now again we will find inner product. Inner product is 3. Now we will find outer product. Outer product is 6. So my inner product is less than outer product. Inner product is less than outer product. So my system is unstable. So my system is unstable. So see, this short trick is so helpful in finding out whether my system is stable or unstable for third order polynomial with all coefficients having positive sign. This trick will give you whether my system is stable or not stable. But again, if you are asked to find number of roots which are lying on the right hand side in case the system is unstable, then in that case you will have to find the Routh array. Then in that case you will have to find the Routh array to find the number of sign changes. I am saying that this short trick is helpful only if it is asked to find whether my system is stable or not stable. But if my system is unstable and it is asked to find number of roots which are lying on right hand side, then you have to form the Routh array and check the number of sign chains. Then only you can conclude. You cannot conclude number of poles on the right hand side of S plane by using this short. So I hope this is clear to you. अब चलो हम लोग कुछ क्वेश्चंस देखते हैं रिलेटेड टू राउथ हर्विट्ज क्राइटेरिया। तो देखो ये क्वेश्चन क्या कह रहा है, नन ऑफ द पोल्स ऑफ ए लीनियर कंट्रोल सिस्टम लाई इन द राइट हाफ ऑफ एस प्लेन. सो फॉर ए बाउंडेड इनपुट द आउटपुट ऑफ दिस सिस्टम विल बी इज ऑलवेज बाउंडेड, could be unbounded, always tend to 0, none of the above. चलो इसको सॉल्व करते हैं। पहले एक बार हम लोग अपना एस प्लेन बना लेते हैं, ठीक है। ये देखो मेरा एस प्लेन है। अब एज पर क्वेश्चन क्या है, ये कह रहा है कि आपका कोई भी पोल RHS पे लाई नहीं कर रहा है। आपका कोई भी पोल RHS पे लाई नहीं कर रहा है। अब कोई भी पोल RHS पे लाई नहीं कर रहा है, इसका मतलब क्या है कि मेरा पोल LHS पे लाई कर सकता है। अगर मेरा सारा पोल LHS पे लाई करेगा फिर तो मेरा सिस्टम स्टेबल हो जाएगा। और हम लोगों को पता है कि अगर मेरे पास एक स्टेबल सिस्टम है, सो फॉर ए बाउंडेड इनपुट हम लोगों को हमेशा एक बाउंडेड आउटपुट मिलेगा, ठीक है। ये तो हम लोगों को पता है कि अगर मेरे पोल्स, मेरे सारे क्लोज लूप पोल्स LHS पे लाई करेगा तब तो मेरा सिस्टम स्टेबल है। और अगर सिस्टम स्टेबल है देन फॉर ए बाउंडेड इनपुट वी विल ऑलवेज गेट अ बाउंडेड आउटपुट। लेकिन देखो क्वेश्चन में कह रहा है कि मेरा पोल RHS पे लाई नहीं कर रहा है, तो एक कंडीशन तो ये बन गया कि मेरे सारे पोल्स LHS पे लाई कर रहे हैं। लेकिन एक और कंडीशन यहाँ पे बन सकता है क्या, कि मेरे पोल्स इमेजिनरी एक्सिस पे भी तो लाई कर सकता है, ठीक है। मेरे सारे पोल्स, मेरे क्वेश्चन में कह रहा है कि पोल्स RHS पे नहीं है, तो मीन्स पोल्स RHS पे नहीं है, इसका मतलब कि या तो वो LHS पे हो सकता है या फिर वो इमेजिनरी एक्सिस पे भी हो सकता है। और हम लोग को पता है कि अगर मेरे पास पोल्स इमेजिनरी एक्सिस में है तो उस केस में मेरा सिस्टम स्टेबल नहीं होता है, पर उस केस में मेरा सिस्टम मार्जिनल स्टेबल होता है। एक और चीज़ क्या हो सकता है कि अगर आपका पोल्स इमेजिनरी एक्सिस पे लाई कर रहा है तो हो सकता है कि इमेजिनरी एक्सिस पे आपको रिपीटेड पोल्स मिल रहे हैं, ये भी तो एक पॉसिबिलिटी है कि आपको इमेजिनरी एक्सिस पे रिपीटेड पोल्स मिल गए, और अगर आपको इमेजिनरी एक्सिस पे रिपीटेड पोल्स मिल गए तो उस केस में मेरा सिस्टम क्या हो जाएगा, उस केस में मेरा सिस्टम अनस्टेबल हो जाएगा। और हम लोग को पता है कि अगर मेरे पास एक अनस्टेबल सिस्टम है तो कोई भी बाउंडेड इनपुट के लिए हम लोगों को बाउंडेड आउटपुट नहीं मिलेगा। तो सारे कंडीशंस को अगर हम लोग लेकर चले या फिर सारे पॉसिबिलिटीज़ को हम लोग लेकर चले तो देखो इसका क्या करेक्ट आंसर होगा, दैट फॉर ए बाउंडेड इनपुट द आउटपुट ऑफ दिस सिस्टम कुड बी अनबाउंडेड। देखो ऑलवेज बाउंडेड तो हम लोग नहीं कह सकते हैं। अगर मेरा वो पोल्स इमेजिनरी एक्सिस पे लाई कर गया तब तो वो मार्जिनल स्टेबल है, ठीक है। तो ज़रूरी नहीं है कि बाउंडेड इनपुट के लिए हम लोग को बाउंडेड आउटपुट ही मिलेगा। और अगर मेरे इमेजिनरी एक्सिस पे रिपीटेड पोल्स मिल गए तब तो मेरा सिस्टम अनस्टेबल हो जाएगा, तब भी हम लोगों को बाउंडेड इनपुट के लिए बाउंडेड आउटपुट नहीं मिलेगा। इसलिए इस क्वेश्चन का करेक्ट ऑप्शन होगा ऑप्शन बी, दैट इज़ फॉर ए बाउंडेड इनपुट मेरा सिस्टम अनबाउंडेड भी हो सकता है अगर क्वेश्चन में बस ये बताया गया है कि कोई भी पोल्स मेरा RHS पे लाई नहीं कर रहा है, ठीक है। आई होप दिस इज क्लियर टू यू। तो चलो आगे चलते हैं। अब चलो नेक्स्ट क्वेश्चन देखते हैं। तो यहाँ पे क्या है, द राउथ हर्विट्ज क्राइटेरिया कैन नॉट बी अप्लाइड व्हेन द कैरेक्टरिस्टिक इक्वेशन ऑफ द सिस्टम कंटेन्स एनी कोएफिशिएंट which is negative real and exponential function of s, negative real both exponential and sinusoidal function of s, both exponential and sinusoidal function of s, complex both exponential and sinusoidal function of s. ऑप्शन डी इज द करेक्ट ऑप्शन। कि अगर हम लोगों ने ये देखा भी था कि राउथ हर्विट्ज क्राइटेरिया हम लोग नहीं अप्लाई कर पाएंगे अगर मेरे पास कॉम्प्लेक्स फंक्शन हो या एक्सपोनेंशियल फंक्शन हो या फिर सिनुसॉइडल फंक्शन ऑफ एस हो, ठीक है। सो आई होप दिस इज क्लियर टू यू। तो चलो आगे चलते हैं। अब चलो नेक्स्ट क्वेश्चन देखते हैं। कंसिडर द फॉलोइंग स्टेटमेंट्स विथ रेस्पेक्ट टू राउथ हर्विट्ज क्राइटेरिया। इट कैन बी यूज्ड टू डिटरमाइन रिलेटिव स्टेबिलिटी, ठीक है। मीन्स हम लोगों ने ये डिस्कस किया भी था कि राउथ हर्विट्ज से हम लोग एब्सोल्यूट स्टेबिलिटी निकालते हैं। एब्सोल्यूट स्टेबिलिटी निकालना हम लोग प्रेफर करते हैं, लेकिन राउथ हर्विट्ज क्राइटेरिया से हम लोग रिलेटिव स्टेबिलिटी भी निकाल सकते हैं। हाँ, रिलेटिव स्टेबिलिटी निकालना थोड़ा सा एक कॉम्प्लेक्स मेथड हो जाता है इफ़ वी आर यूजिंग राउथ हर्विट्ज क्राइटेरिया, लेकिन कोई अगर पूछे कि निकाल सकते हैं कि नहीं तो आप बोलोगे कि हम लोग बिल्कुल निकाल सकते हैं, ठीक है। इट इज़ वैलिड ओनली फॉर रियल कोएफिशिएंट्स ऑफ द कैरेक्टरिस्टिक इक्वेशन, ये भी ठीक है। इट इज़ एप्लीकेबल ओनली फॉर नॉन लीनियर सिस्टम, ये तो ठीक नहीं है, हम लोग लीनियर सिस्टम के लिए भी अप्लाई कर सकते हैं। इट डज नॉट प्रोवाइड द एग्जैक्ट लोकेशन ऑफ क्लोज लूप पोल्स इन लेफ्ट और राइट हाफ ऑफ एस प्लेन, ये भी सही है। एग्जैक्ट लोकेशन तो नहीं बताता है, हम लोग को बेसिकली वो एक अप्रॉक्स इंडिकेशन देता है रिगार्डिंग द पोजिशनिंग ऑफ क्लोज लूप पोल्स। तो मेरा करेक्ट ऑप्शन हो जाएगा ऑप्शन सी। नेक्स्ट क्वेश्चन चलते हैं। कंसिडर द फॉलोइंग स्टेटमेंट्स अबाउट राउथ हर्विट्ज क्राइटेरिया। इफ ऑल द एलिमेंट्स इन वन रो ऑफ राउथ एरे आर जीरो देन देयर आर, इफ ऑल द एलिमेंट्स इन वन रो ऑफ राउथ एरे आर जीरो then there are pairs of conjugate poles on the imaginary axis। हाँ, imaginary axis पे हम लोगों को poles मिलेगा। pairs of equal real roots with opposite sign, pairs of equal real roots with opposite sign, ये भी ठीक है, ये भी possibility हो सकता है। Conjugate roots forming a quadrate in the S plane, conjugate roots forming a quadrate in the S plane, ये भी सही है। अगर मेरा कोई भी एक रो ज़ीरो हो जाता है तो हम लोग को पता है कि मेरे जो क्लोज लूप पोल्स हैं वो मेरे ओरिजिन के अराउंड सिमेट्रिक होंगे, और अगर ओरिजिन के अराउंड सिमेट्रिक होंगे तो मेरे पास ये पॉसिबिलिटी है कि मेरे जो पोल्स है वो इमेजिनरी एक्सिस में लाई कर सकता है एज कॉन्जुगेट रूट्स, ठीक है। अब देखो LHS पे भी वो लाई कर सकता है एज कॉन्जुगेट रूट्स, और अगर देखो यहाँ पे LHS पे वो लाई कर गया तो सेम हम लोग का एक रेप्लिका RHS पे भी वो लाई करेगा एज कॉन्जुगेट रूट्स। तो ये चार मिला के मेरा वो एक क्वाड्रेट बन सकता है, ठीक है। तो मेरे तीनों ऑप्शन सही है, सो ऑप्शन डी इज द करेक्ट ऑप्शन। अब चलो नेक्स्ट क्वेश्चन देखते हैं। फॉर ए स्टेबल फीडबैक कंट्रोल सिस्टम द zeros of the characteristic equation must all be located in the left half of S plane. रीज़न है द पोल्स ऑफ द क्लोज लूप ट्रांसफर फंक्शन आर द जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन। हाँ देखो, ये क्वेश्चन उठाने का मेरा मेन मकसद था कि आप इस टर्म से थोड़ा सा अवेयर हो जाओ। देखो, जब भी बहुत बार ना आपको एग्जामिनर क्या कहेगा कि जब आपको कैरेक्टरिस्टिक इक्वेशन वो दे रहा है ना, तो बहुत बार वो जो मेरे पोल्स ऑफ कैरेक्टरिस्टिक इक्वेशन है उसे वो जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन से भी डिनोट करता है, ठीक है। तो ये आपको पता होना चाहिए कि मेरे जो जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन है इट इज़ नथिंग बट माई पोल्स ऑफ कैरेक्टरिस्टिक इक्वेशन। तो मेरे जो पोल्स ऑफ कैरेक्टरिस्टिक इक्वेशन है उसे हम लोग जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन से भी डिनोट करते हैं। ये आपको पता होना चाहिए। ऐसा ना हो कि एग्जाम में आप ये जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन देखकर थोड़ा सा कंफ्यूज हो जाओ कि यार ये कैरेक्टरिस्टिक इक्वेशन में ये जीरोज कहाँ से आ गया, ठीक है। तो ठीक है, बाकी तो फिर ये इसमें कुछ है ही नहीं। फॉर ए स्टेबल फीडबैक कंट्रोल सिस्टम, अगर मेरे पास एक फीडबैक कंट्रोल सिस्टम स्टेबल है तो ऑब्वियस सी बात है उसके मेरे जितने भी क्लोज लूप पोल्स हैं या फिर मेरे जो जीरोज है ऑफ कैरेक्टरिस्टिक इक्वेशन वो सारे मेरे LHS ऑफ S प्लेन पे लाई करना चाहिए। और यहाँ पे कह रहा है कि द पोल्स ऑफ द क्लोज लूप ट्रांसफर फंक्शन आर नथिंग बट माई जीरोज ऑफ कैरेक्टरिस्टिक इक्वेशन। तो मेरा ये ऑप्शन ए, यहाँ पे बेसिकली ABCD ऑप्शन है नहीं, इसमें आपका ऑप्शन ए सही रहेगा कि मेरा ए सही है एंड द रीज़न आर इज़ परफेक्टली जस्टिफाइंग माई असर्शन, इज़ परफेक्टली जस्टिफाइंग माई गिवन असर्शन, ठीक है। तो चलो आगे चलते हैं। Coming to the next question. In order to use Routh Hurwitz criteria for determining the stability of sampled data system, the characteristic equation 1 plus zz hz is equal to 0 should be modified by using bilinear transform. देखो, जब मैं प्रीवियस ईयर क्वेश्चंस रेफर कर रहा था ना ऑफ इलेक्ट्रॉनिक्स एंड इलेक्ट्रिकल ब्रांच ऑफ ESE प्री, तो मुझे ये क्वेश्चन अराउंड 3 बार मिला, ठीक है। इसलिए मैं इस क्वेश्चन को यहाँ पे इंक्लूड कर रहा हूँ, जिससे क्या है कि अगर नेक्स्ट टाइम आपको ये क्वेश्चन मिले तो आप वहाँ पे करेक्ट ऑप्शन टिक कर देना। तो यहाँ पे मेरा करेक्ट ऑप्शन है ऑप्शन डी, ठीक है। कि अगर हम लोग बाइलीनियर ट्रांसफॉर्म यूज़ कर रहे हैं, तो अगर हम लोग बाइलीनियर ट्रांसफॉर्म यूज़ कर रहे हैं तो मेरा बाइलीनियर ट्रांसफॉर्म क्या हो जाएगा, z इज इक्वल टू r+1 बाई r-1, ठीक है। दिस इज़ योर करेक्ट ऑप्शन। ये आप अपने शॉर्ट नोट्स में भी मेंशन कर लेना, जिससे आपको क्या है कि इस क्वेश्चन, ये अगर क्वेश्चन आता है तो आप डायरेक्टली इसमें करेक्ट ऑप्शन टिक कर सको, ठीक है। ये अराउंड 3 बार तो प्रीवियस ईयर क्वेश्चंस में पूछा ही गया है इन योर इलेक्ट्रॉनिक्स एंड इलेक्ट्रिकल ब्रांच, ठीक है। तो चलो आगे चलते हैं। अब चलो इस क्वेश्चन को देखते हैं। तो यहाँ पे क्या कह रहा है कि फॉर ए सिस्टम टू बी स्टेबल ऑल कोएफिशिएंट्स ऑफ द कैरेक्टरिस्टिक पॉलिनोमियल मस्ट बी पॉजिटिव, ठीक है। रीज़न में क्या कह रहा है, ऑल पॉजिटिव कोएफिशिएंट्स ऑफ द कैरेक्टरिस्टिक इक्वेशन ऑफ ए सिस्टम इज ए सफिशिएंट कंडीशन फॉर स्टेबिलिटी। ये चीज़ देखो हम लोगों ने देखा भी था कि ऑल पॉजिटिव कोएफिशिएंट्स ऑफ द कैरेक्टरिस्टिक पॉलिनोमियल इज द रिक्वायर्ड कंडीशन बट इट इज़ नॉट द सफिशिएंट कंडीशन फॉर स्टेबिलिटी। तो ये आपका ऑप्शन सी होगा। ये हम लोगों ने बहुत डिटेल्स में भी देखा था कि अगर आपके पास एक कैरेक्टरिस्टिक इक्वेशन है और उसमें सारे कोएफिशिएंट्स पॉजिटिव है तो ज़रूरी नहीं है कि मेरा सिस्टम स्टेबल होगा। लेकिन हाँ, अगर आपके पास एक कैरेक्टरिस्टिक इक्वेशन है जिसमें आपके पास कुछ कोएफिशिएंट्स नेगेटिव है या मिसिंग है, तो उस केस में आपका सिस्टम तो अनस्टेबल हो जाएगा, पक्का है। लेकिन अगर सारे कोएफिशिएंट्स आपके पॉजिटिव है तो ये आपका गारंटी नहीं करता है कि आपका सिस्टम स्टेबल होगा ही। उसके लिए आपको RH क्राइटेरिया अप्लाई करके चेक करना पड़ेगा। तो चलो आगे चलते हैं। अब चलो ये क्वेश्चन देखते हैं। तो यहाँ पे आपको कह रहा है ए यूनिटी फीडबैक कंट्रोल सिस्टम इज कैरेक्टराइज्ड बाय द ओपन लूप ट्रांसफर फंक्शन जी ऑफ एस दिया गया है। आपको कह रहा है टू फाइंड द वैल्यू ऑफ के, आपको कह रहा है टू फाइंड द वैल्यू ऑफ के फॉर विच द सिस्टम ऑसिलेट्स एट 2 रेडियन पर सेकेंड। ठीक है, तो देखो इस क्वेश्चन को हम लोग 2 मेथड से सॉल्व कर सकते हैं। पहला मेथड देखते हैं। तो यहाँ पे देखो आपका कैरेक्टरिस्टिक इक्वेशन आप निकाल लोगे फ्रॉम गिवन जी ऑफ एस, वहाँ से आप राउथ हर्विट्ज़ टेबल बना लो, राउथ टेबल आप बना लोगे। ठीक है, राउथ टेबल आप कुछ इस तरह से बना लोगे। अब देखो यहाँ पे आपको क्वेश्चन में क्या दे रहा है, देखो आपको यहाँ पे ऑसिलेटिंग फ्रीक्वेंसी दे रहा है 2 रेडियन पर सेकेंड। अब हम लोग को पता है कि अगर हम लोग को ऑसिलेटिंग फ्रीक्वेंसी निकालना है तो उसके लिए हम लोगों को ऑक्सिलरी इक्वेशन को रेफर करना पड़ेगा। तो देखो इस केस में मेरा ऑक्सिलरी इक्वेशन क्या हो जाएगा, इट विल बी इक्वल टू के एस स्क्वायर प्लस 3 इज इक्वल टू 0। इसको अगर हम लोग फर्दर सॉल्व करें तो यहाँ पे मेरा s आ जाएगा प्लस माइनस जे रूट 3/k। अब देखो हम लोग का जो ऑसिलेटिंग फ्रीक्वेंसी है वो हम लोग को दे दिया है 2 रेडियन पर सेकेंड। तो देखो यहाँ पे हम लोग s को रिप्लेस कर देंगे बाई 2j। ठीक है, तो यहाँ से मेरा जो k है वो आ जाएगा 3/4, ये आ जाएगा 3/4। ठीक है, तो ये तो मेरा मेथड 1 हो गया। अब मेथड 2 क्या है, अब देखो मेरा सिस्टम में क्या कह रहा है कि मेरा जो सिस्टम है वो ऑसिलेट कर रहा है। मेरा क्वेश्चन में क्या कह रहा है कि मेरा सिस्टम ऑसिलेट कर रहा है। अब देखो मेरा अगर सिस्टम ऑसिलेट करेगा, इसका मतलब क्या है कि मेरा जो रूट्स है वो मेरे इमेजिनरी एक्सिस पे लाई करना चाहिए। और अगर रूट्स इमेजिनरी एक्सिस पे लाई करेगा इट मीन्स कि मेरा जो यहाँ पे S1 रो है ये मेरा 0 होना चाहिए। देखो मेथड 2 फिर से समझो। मेथड 2 क्या है, क्वेश्चन में कह रहा है कि मेरा जो सिस्टम है वो ऑसिलेट कर रहा है और वो ऑसिलेट कर रहा है विथ ए फ्रीक्वेंसी ऑफ 2 रेडियन पर सेकेंड। अब हम लोग को पता है कि अगर मेरा सिस्टम ऑसिलेट करेगा इट मीन्स कि मेरा जो क्लोज लूप पोल्स है वो इमेजिनरी एक्सिस पे लाई करना चाहिए। और अगर पोल्स इमेजिनरी एक्सिस पे लाई कर रहा है तो इसका मतलब ये है कि मेरा जो S1 रो है वो 0 होना चाहिए। तो S1 रो को 0 कर दो। इसके लिए हम लोग क्या कर देंगे, 4k माइनस 3/k इज इक्वल टू 0 कर देंगे। तो यहाँ से भी मेरा k इज इक्वल टू 3/4 आ गया। तो इस क्वेश्चन को बेसिकली हम लोग 2 मेथड से सॉल्व करते हैं। दोनों मेथड हम लोग को करेक्ट ऑप्शन देंगे। तो चलो आगे चलते हैं। अब चलो ये क्वेश्चन देखते हैं। तो यहाँ पे क्या कह रहा है, विच ऑफ द फॉलोइंग ऑप्शंस करेक्टली डिस्क्राइब्स द लोकेशन ऑफ द रूट्स ऑफ द इक्वेशन S4 प्लस S2 प्लस 1 इज इक्वल टू 0 ऑन द कॉम्प्लेक्स प्लेन। चलो इसको सॉल्व करते हैं। देखो कैरेक्टरिस्टिक इक्वेशन हम लोग को दे दिया है S4 प्लस S2 प्लस 1 इज इक्वल टू 0। इसका हम लोग राउथ टेबल बनाते हैं। ठीक है, तो देखो जब हम लोग राउथ टेबल बनाएंगे तो हम लोग देख सकते हैं कि मेरा जो S3 रो है वो 0 हो जा रहा है। ठीक है, S3 रो 0 हो जा रहा है। तो अब हम लोग को अपने राउथ टेबल को कंप्लीट करना है तो उसके लिए हम लोग अपना ऑक्सिलरी इक्वेशन रेफर करेंगे। तो मेरा जो ऑक्सिलरी इक्वेशन है वो आ जाएगा इसके S3 के ऊपर वाला, दैट इज S4 प्लस S स्क्वायर प्लस 1 इज इक्वल टू 0। फिर हम लोग ऑक्सिलरी इक्वेशन को डिफ्रेंशिएट कर देंगे विद रेस्पेक्ट टू S। तो ये आ जाएगा 4S³ प्लस 2S इज इक्वल टू 0। और यहाँ से हम लोग अपना S3 रो जो 0 हो गया था उसे हम लोग फर्दर कंटिन्यू कर लिए। ठीक है, अब इसके बाद हम लोग फर्दर अपना राउथ टेबल कंप्लीट करते हैं। तो S2 यहाँ आ जाएगा, S1 यहाँ आ जाएगा, S0 यहाँ आ जाएगा। तो ये आ गया मेरा कंप्लीट राउथ टेबल। अब हम लोग को चेक करना है कि कौन से पोल कहाँ पे लाई कर रहा है। ठीक है, तो देखो सबसे पहला क्या है, मेरा जो S3 रो है ये मेरा 0 हो रहा है। S3 रो 0 हो रहा है, इट मीन्स कि मेरा ऑक्सिलरी इक्वेशन क्या है, यहाँ से हम लोग ऑक्सिलरी इक्वेशन ले रहे हैं, दैट इज S4 प्लस एस स्क्वायर प्लस 1 इज इक्वल टू 0। तो यहाँ से हम लोग को फर्स्ट कंक्लूजन क्या मिला कि मेरे 4 पोल्स हैं विच आर सिमेट्रिकल अबाउट ओरिजिन। 4 poles are symmetrical about origin। अब हम लोग चेक करते हैं कि ऑक्सिलरी इक्वेशन के नीचे मेरा कितना साइन चेंज हो रहा है। तो देखो पहला साइन चेंज हुआ यहाँ, दूसरा साइन चेंज हुआ ये, मीन्स 2 साइन चेंज हो रहा है। 2 साइन ऑक्सिलरी इक्वेशन के नीचे मेरा 2 साइन चेंज हो रहा है। इसका मतलब क्या होगा, 2 पोल्स विल लाई ऑन RHS, और ये जो मेरे 2 पोल्स RHS पे लाई कर रहे हैं वो मेरे सिमेट्रिकल अबाउट ओरिजिन भी होंगे, एंड दे आर सिमेट्रिकल अबाउट ओरिजिन। ठीक है, तो ये 2 कंक्लूजन हम लोग निकाल लिए। अगर ये 2 कंक्लूजन निकाल लिए तो देखो अब हम लोग ईजिली अपने पोल्स को लोकेट कर सकते हैं। यहाँ पे देखो क्या है, मेरे 2 पोल्स हैं जो RHS पे लाई करेंगे, और ये कह रहा है कि ये जो 2 पोल्स मेरे RHS पे लाई किए ये मेरे सिमेट्रिकल अबाउट ओरिजिन भी होना चाहिए, मीन्स LHS पे भी हम लोग अपना 2 पोल लाई कराएंगे। ये दोनों देखो सिमेट्रिकल है और ये दोनों मेरा सिमेट्रिकल है। ठीक है, तो हम लोग का जो कैरेक्टरिस्टिक इक्वेशन था उसका पावर 4 था, मीन्स जो मेरे टोटल पोल्स है वो 4 है, और चारों पोल्स का लोकेशन हम लोगों ने यहाँ पे फाइंड आउट कर लिया, 2 LHS पे 2 RHS पे। तो मेरा जो करेक्ट ऑप्शन होगा वो हो जाएगा ऑप्शन सी। तो अगर आपको कॉन्सेप्ट क्लियर है तो इस तरह के क्वेश्चंस को आप इजीली सॉल्व कर लोगे। हाँ, अगर आपका कॉन्सेप्ट क्लियर नहीं है तब आप यहाँ पे फंस जाओगे, यहाँ पे आप फिर सिली मिस्टेक करोगे। तो हम लोगों ने जितना भी थ्योरी देखा है उसके बाद मुझे लगता नहीं है कि आपको किसी भी क्वेश्चन में डिफ़िकल्टी आएगा। तो चलो आगे चलते हैं। अब चलो नेक्स्ट क्वेश्चन देखते हैं। ये आपका क्या कह रहा है, कंसिडर द यूनिटी फीडबैक कन्फिगरेशन with a plant and a PID controller as shown in figure। G of S दे दिया 1 by S plus 1 S plus 3, C of S दे दिया आपका K S plus 3 minus J, ये आपका minus J है, ठीक है, और S plus 3 plus J by S with K being scalar। The closed loop is this, stable for all values of K, only stable for K between -1 1, only stable for K less than 0, only stable for K greater than 0। तो चलो इसको सॉल्व करते हैं। सबसे पहले हम लोगों ने अपना कैरेक्टरिस्टिक इक्वेशन निकाल लिया। तो हम लोग देख सकते हैं कि मेरा जो कैरेक्टरिस्टिक इक्वेशन है वो मेरा एक 3rd ऑर्डर का है। तो यहाँ पे हम लोग अपना शॉर्टकट लगा लेते हैं। सबसे पहले हम लोग अपना जो इनर प्रोडक्ट है वो निकाल लेते हैं। इनर प्रोडक्ट आ गया K + 4 6K + 3। आउटर प्रोडक्ट निकाल लेते हैं, वो आ जाएगा 10K। अब हम लोग को पता है फॉर ए सिस्टम टू बी स्टेबल माय इनर प्रोडक्ट शुड बी ग्रेटर देन आउटर प्रोडक्ट। अब इस वाले इक्वेशन को अगर हम लोग सॉल्व करें तो देखो फाइनली हम लोग को ये इक्वेशन मिल जा रहा है। अब हम लोग क्या करेंगे, गिवन ऑप्शन में से हम लोग मैच कराएंगे। हम लोगों को बेसिकली ये इक्वेशन को मीट करना है। अगर मेरा ये इक्वेशन मीट कर रहा है तो मेरा सिस्टम स्टेबल होगा। अब देखो इस इक्वेशन को मीट करने के लिए मेरा कौन सा ऑप्शन सबसे बेस्ट है। देखो ये कह रहा है स्टेबल फॉर ऑल वैल्यूज़ ऑफ K। अब देखो ऑल वैल्यूज़ ऑफ K कह रहा है, अगर यहाँ पे हम K का वैल्यू नेगेटिव ले लिए तो क्या मेरा ये इक्वेशन मीट होगा? नहीं होगा। अगर मान लो हम K का वैल्यू -1 ले लेते हैं, अगर हम K का वैल्यू -1 ले लेते हैं, मान लो मेरा K का वैल्यू आ गया -1, तो हमें क्या मिल जाएगा? देखो यहाँ आ गया 6, या फिर K का वैल्यू हम लोग ले लेते हैं -2 लेते हैं। देखो K का वैल्यू हम लोग ले लेते हैं 1, ठीक है। K का वैल्यू अगर हम लोग 1 ले लिए तो देखो हम लोग को क्या मिल जाएगा, ये मिल गया 6, सॉरी K का वैल्यू ले लेते हैं हम लोग -1, तो ये आ गया 6 ये आ गया -17, ये आ गया 12। तो ये आपका क्या हो जाएगा, तो देखो ये हम लोगों को फाइनली कितना मिल जाएगा, ये मिल जाएगा 1 एंड 1 इज़ ग्रेटर देन 0। तो k इज़ इक्वल टू -1 के लिए तो ये सेटिस्फाई हो गया। ठीक है, अब हम लोग पुट करते हैं k इज़ इक्वल टू -1.5। तो k इज़ इक्वल टू -1.5 में देखो हम लोगों को क्या मिलेगा, ये मिल जाएगा आपका 1.5, ये आ जाएगा आपका 13.5 प्लस 12 भी कर दिए, तो ये आप डायरेक्टली लिख दो 25.5। और यहाँ पे अगर आप 17 को मल्टीप्लाई कर रहे हो, 17 इंटू 1.5, तो ये भी आ जाएगा आपका 25.5। तो ये आ गया आपका 0, और हम लोग देख सकते हैं कि 0 मेरा ग्रेटर देन 0 तो है नहीं, तो इसलिए मेरा जो ये फर्स्ट ऑप्शन है दैट किसी भी वैल्यू ऑफ k के लिए मेरा सिस्टम स्टेबल होगा, इट इज़ नॉट द करेक्ट ऑप्शन। ठीक है, इसी तरह ओनली स्टेबल फॉर k बिटवीन -1 +1, यहाँ भी आप वैल्यूज़ पुट करके चेक कर सकते हो। हम लोग का इक्वेशन ये वाला जो इक्वेशन है ये सेटिस्फाई नहीं होगा। और इसी तरह ऑप्शन सी के लिए भी, ऑप्शन सी तो अभी हम लोगों ने चेक कर भी लिया, -1.5 के लिए मेरा इक्वेशन सेटिस्फाई नहीं हो रहा था। तो आपका जो करेक्ट ऑप्शन है वो आएगा आपका ऑप्शन डी, दैट इज़ ओनली स्टेबल फॉर k ग्रेटर देन 0। मीन्स पॉजिटिव वैल्यू ऑफ k के लिए मेरा ये इक्वेशन सेटिस्फाई करेगा। वो तो हम लोग को दिख भी रहा है कि अगर मेरा k का वैल्यू पॉजिटिव है तो ये वाला इक्वेशन मेरा हर एक कंडीशन में सेटिस्फाई करेगा। ठीक है, सो आई होप दिस इज़ क्लियर टू यू। तो चलो आगे चलते हैं। अब चलो नेक्स्ट क्वेश्चन देखते हैं। तो यहाँ पे क्या है, द नंबर ऑफ रूट्स ऑफ पॉलिनोमियल। आपको एक पॉलिनोमियल दे दिया है जो कि आपका लाई कर रहा है ऑन लेफ्ट हाफ ऑफ द कॉम्प्लेक्स प्लेन। ठीक है, तो देखो इसके सबसे पहले हम लोग राउथ टेबल बना लेते हैं। तो आप राउथ टेबल बनाओगे तो आप यहाँ तक पहुँच जाओगे, S4 तक पहुँच जाओगे। आप जब S3 रो देखोगे तो आपका S3 रो 0 आ जाएगा। ठीक है, S3 रो मेरा 0 आ गया। तो अब हम लोग अपने राउथ टेबल को कंप्लीट करने के लिए ऑक्सिलरी इक्वेशन का हेल्प लेंगे। तो ये मेरा ऑक्सिलरी इक्वेशन है, इसको डिफ्रेंशिएट कर देंगे। तो यहाँ से अब मेरा जो ये S3 रो है, ये अब मेरा इसका यहाँ पे हम लोग वैल्यूज़ पुट कर देंगे, और इस वैल्यूज़ को लेके अब जो मेरा रिमेनिंग राउथ टेबल है वो हम लोग कंप्लीट करेंगे। तो ये S2 रो आ गया, ये S1 रो आ गया, ये मेरा S0 रो आ गया। ठीक है, अब हम लोग ये देखते हैं कि मेरा जो रूट्स है वो किस तरह और कहाँ कहाँ पे लाई कर रहा है। ठीक है, तो देखो यहाँ पे क्या है, मेरा S3 रो 0 है। ठीक है, S3 रो 0 है तो मेरा ऑक्सिलरी इक्वेशन आ गया 8S4 प्लस 48S² प्लस 200 इज इक्वल टू 0। ऑक्सिलरी इक्वेशन का ऑर्डर कितना है, 4। इसका मतलब क्या आ गया, मेरे 4 रूट्स हैं जो मेरे सिमेट्रिकल अबाउट ओरिजिन है। मेरे 4 रूट्स हैं जो मेरे सिमेट्रिकल अबाउट ओरिजिन है। ठीक है, तो हम लोग यहाँ पे फर्स्ट कंक्लूजन तो लिख सकते हैं, 4 poles are symmetrical about origin। ठीक है, अब देखो क्या करना है। अब हम लोग चेक करते हैं कि मेरा जो ऑक्सिलरी इक्वेशन है उसके नीचे मेरा जो ऑक्सिलरी इक्वेशन वाला जो रो है उसके नीचे हम लोगों को कितना साइन चेंज मिल रहा है। तो देखो यहाँ पे हम लोगों को कितना साइन चेंज मिला, 1 साइन चेंज, 2 साइन चेंज। तो देखो ऑक्सिलरी इक्वेशन के नीचे, ऑक्सिलरी इक्वेशन का जो रो है उसके नीचे हम लोगों को 2 साइन चेंज मिला। इट मीन्स कि मेरा 2 पोल्स will lie on RHS, और ये जो लाई कर रहा है ऑन RHS, एंड दे will be symmetrical about origin. ऑक्सिलरी इक्वेशन के नीचे, ऑक्सिलरी इक्वेशन का जो रो है, ऑक्सिलरी इक्वेशन का जो रो है उसके नीचे जो मेरा साइन चेंज है वो 2 साइन चेंज हो रहा है. इट मीन्स कि वो मेरे 2 पोल्स RHS पे लाई करेंगे और वो मेरा सिमेट्रिकल अबाउट ओरिजिन भी होगा. अब जो ये ऑक्सिलरी इक्वेशन है, ये जो रो है या फिर इसके ऊपर जो रो है, यहाँ पे आपको कितने साइन चेंज मिल रहे हैं? यहाँ पे आप देखो आपको कितने साइन चेंज मिल रहे हैं. अब देखो मेरा जो ऑक्सिलरी इक्वेशन का जो रो है इसको मिला लो और इसके ऊपर वाले रोज को देख लो. अब देखो यहाँ पे मेरे कितने साइन चेंज हो रहे हैं. तो यहाँ पे हम लोग देख सकते हैं कि मेरा 1 साइन चेंज हुआ, 2 साइन चेंज हुआ. ठीक है, तो यहाँ पे हम लोग इसको कंक्लूड करो. इसके चक्कर में हम लोग को एक और कंक्लूजन मिला कि मेरे 2 पोल्स विल लाई ऑन RHS. लेकिन अब जो ये मेरे पोल RHS पे लाई किए ना, ये मेरे सिमेट्रिकल नहीं होंगे अबाउट ओरिजिन, बट दे विल नॉट बी सिमेट्रिकल अबाउट ओरिजिन. मेरा जो ऑक्सिलरी इक्वेशन का जो रो है उसके नीचे अगर साइन चेंज हो रहा है तो वो मेरे सिमेट्रिकल अबाउट ओरिजिन होते हैं. लेकिन ऑक्सिलरी इक्वेशन का रो ले लो या उसके ऊपर का रोज ले लो, वहाँ पे अगर आपका साइन चेंज हो रहा है तो वो मेरे सिमेट्रिकल अबाउट ओरिजिन नहीं होगा. ठीक है, तो अब देखो मेरे टोटल पोल्स कितने हैं? टोटल पोल 7 है, क्योंकि कैरेक्टरिस्टिक इक्वेशन का ऑर्डर 7 है. ठीक है, अब यहाँ पे हम लोग को क्या मिला कि 4 पोल्स मेरे सिमेट्रिकल अबाउट ओरिजिन होने चाहिए. ठीक है, यहाँ से मिला 2 पोल्स RHS पे होने चाहिए और वो सिमेट्रिकल अबाउट ओरिजिन भी होना चाहिए. तो देखो यहाँ पे आप 2 पोल्स डाल दो RHS पे और इसका काउंटर पार्ट आपका LHS पे भी आएगा, क्योंकि ये सिमेट्रिकल अबाउट ओरिजिन है. तो हम लोग देख सकते हैं कि मेरे 4 पोल्स सिमेट्रिकल अबाउट ओरिजिन आ गए. इट मीन्स कि मेरा पहला कंडीशन मीट हो गया. और फिर 2 पोल्स RHS पे लाई कर रहा है और वो सिमेट्रिकल अबाउट ओरिजिन होना चाहिए, ये वाला कंडीशन भी मीट हो गया. अब तीसरा कंडीशन क्या है कि मेरा 2 और पोल RHS पे होना चाहिए, लेकिन वो सिमेट्रिकल अबाउट ओरिजिन नहीं होना चाहिए. तो ये देखो मेरे 2 पोल्स आप और RHS पे डाल दो, लेकिन ये सिमेट्रिकल अबाउट ओरिजिन नहीं होना चाहिए. ठीक है, तो ये मेरे यहाँ पे पड़े रहेंगे. तो अब मेरे कितने आ गए? 1 2 3 4 5 6 आ गए. ठीक है, अब मेरे और कोई भी पोल सिमेट्रिकल अबाउट ओरिजिन तो नहीं होना चाहिए. इट मीन्स कि अब हम लोग कोई भी पोल यहाँ पे इमेजिनरी एक्सिस पे नहीं डाल सकते हैं, क्योंकि अगर हम लोग डालेंगे इमेजिनरी एक्सिस में तो हम लोग को यहाँ पे 2 पोल्स डालना पड़ेगा. अब क्या 2 पोल्स के लिए हम लोग के पास अवेलेबल पोल्स है? नहीं है. देखो ऑलरेडी मेरे 6 पोल तो कंज्यूम हो गए. टोटल पोल्स थे मेरे 7. तो हम लोग इमेजिनरी एक्सिस में तो पोल्स डाल ही नहीं सकते हैं, क्योंकि इमेजिनरी एक्सिस में जो भी पोल्स आएगा वो मेरे पेयर्स में आते हैं. तो अब मेरा जो रिमेनिंग 7th पोल है वो आ जाएगा मेरा LHS पे. तो अब मेरे क्वेश्चन में क्या पूछ रहा था? मेरे क्वेश्चन में आपसे वो ये पूछ रहा था कि फाइंड द नंबर ऑफ पोल्स विच आर ऑन द LHS ऑफ एस प्लेन. तो देखो मेरे LHS पे कितने पोल्स आ गए? मेरे LHS पे टोटल 3 पोल्स आ गए. 3 पोल्स आ गए इन LHS. तो ये बहुत इंपॉर्टेंट क्वेश्चन था. हम लोगों ने जो कॉन्सेप्ट देखा है वो सारे कॉन्सेप्ट यहाँ पे इंक्लूड हो जा रहे हैं. सो आई होप दिस इज क्लियर टू यू. तो चलो आगे चलते हैं. अब चलो नेक्स्ट क्वेश्चन में चलते हैं. तो इसमें क्या कह रहा है? इन द फॉर्मेशन ऑफ राउथ हर्विट्ज एरे फॉर ए पॉलिनोमियल ऑल द एलिमेंट्स ऑफ ए रो हैव ज़ीरो वैल्यूज़, मतलब कह रहा है कि कोई भी एक रो आपका ज़ीरो हो गया. सो दिस प्री मैच्योर टर्मिनेशन ऑफ द एरे इंडिकेट्स द प्रेजेंस ऑफ ओनली वन रूट एट द ओरिजिन, इमेजिनरी रूट्स, पॉजिटिव रियल रूट्स, निगेटिव रियल रूट्स. तो ठीक है, ये तो अपना इमेजिनरी रूट्स होगा. अगर कोई भी मेरा रो ज़ीरो हो जाता है देन वी विल गेट इमेजिनरी रूट्स. अब चलो इस क्वेश्चन को देखते हैं. तो यहाँ पे आपको एक फीडबैक सिस्टम दिया गया है और आपका कह रहा है कि ये ऑसिलेट कर रहा है एट 2 रेडियन पर सेकेंड, और आपको कह रहा है टू फाइंड वैल्यू ऑफ ए एंड वैल्यू ऑफ के. तो चलो इसका कैरेक्टरिस्टिक इक्वेशन तो आपको ये दिया गया है, तो हम लोग सबसे पहले इसका राउथ टेबल बना लेते हैं. तो राउथ टेबल आपका कुछ इस तरह से बना आ जाएगा. ठीक है, अब आपका क्या कह रहा है कि मेरा सिस्टम ऑसिलेट कर रहा है. सिस्टम ऑसिलेट कब करेगा? सिस्टम ऑसिलेट करेगा जब मेरे रूट्स इमेजिनरी एक्सिस पे लाई करेगा. रूट्स इमेजिनरी एक्सिस पे लाई करने का मतलब क्या है कि मेरा जो S1 रो है वो ज़ीरो हो जाएगा. तो S1 रो को हम लोग ज़ीरो कर देते हैं. तो अगर हम लोग S1 रो को ज़ीरो किए तो देखो हम लोग को जो पहला इक्वेशन है वो मिल गया A इज़ इक्वल टू K+1 डिवाइड बाई K+2. ठीक है, अब क्वेश्चन में देखो हम लोग को एक और इन्फॉर्मेशन दिया गया है. हम लोग को जो ऑसिलेटिंग फ्रीक्वेंसी है वो दे दिया है 2 रेडियन पर सेकेंड. अब हम लोग को पता है कि ऑसिलेटिंग फ्रीक्वेंसी निकालने के लिए हम लोगों को यूज़ करना पड़ेगा अपना ऑक्सिलरी इक्वेशन. तो मेरा जो ऑक्सिलरी इक्वेशन है वो आ जाएगा AS² प्लस K+1 इज इक्वल टू 0. अब इसको अगर हम लोग फर्दर सॉल्व करें, यहाँ पे अगर हम लोग फर्दर इसको सॉल्व करने जाएं तो ये आ गया S इज इक्वल टू प्लस माइनस J रूट K+1 बाई A. ठीक है, अब देखो यहाँ पे मेरा ऑसिलेटिंग, इसको हम लोग ऐसे भी कर सकते हैं, इसको हम लोग ऐसे भी कर सकते हैं, इसको चलो आप ऐसे कर लो. देखो एक स्टेप बना देते हैं. S क्या आ जाएगा आपका 2J प्लस माइनस J रूट K+1 बाई A. ठीक है, तो यहाँ से आपका क्या आ जाएगा, यहाँ से आपको मिल जाएगा A इज इक्वल टू K+1 बाई 4. ये आ गया आपका इक्वेशन 2. अब इक्वेशन 1 एंड इक्वेशन 2 को अगर हम लोग मैच किए तो हम लोग को क्या मिल जाएगा. देखो इक्वेशन 1 एंड इक्वेशन 2 को अगर हम लोग इक्वेट कर दिए तो हम लोग को कुछ इस तरह से मिल जाएगा. यहाँ से मेरा K का वैल्यू आ जाएगा 2. K का वैल्यू 2 आ गया, इक्वेशन 1 में पुट कर दो या इक्वेशन 2 में पुट कर दो तो आपका A का वैल्यू आ जाएगा 3/4. दैट इज 0.7. तो ठीक है, आई होप दिस इज क्लियर टू यू. तो चलो आगे चलते हैं. अब चलो इस क्वेश्चन को देखते हैं. तो यहाँ पे देखो आपको राउथ टेबल का जो पहला 2 रो है S3 रो एंड S2 रो, इसको हम लोगों ने लिख लिया है. अब आपका कह रहा है कि बताओ मेरे रूट्स कहाँ पे लाई कर रहे हैं. तो चलो इसको सॉल्व करते हैं. तो अपने राउथ टेबल में देखो ये जो पहला 2 रो है ये हम लोग को दे दिया गया था. अब फर्दर हम लोग सॉल्व करते हैं. तो देखो यहाँ पे मेरा S1 रो 0 हो गया. S1 रो 0 हो गया तो हम लोग अपना जो ऑक्सिलरी इक्वेशन है वो निकाल लेते हैं. इसको डिफ्रेंशिएट कर देंगे तो हम लोग का जो S1 रो है वो कंप्लीट हो जाएगा. अब फाइनली आ गया मेरा S0 रो. अब हम लोग को देखना है कि मेरे पोल्स कहाँ पे लाई कर रहे हैं. देखो S1 रो 0 हो गया. ठीक है, और मेरा जो ऑक्सिलरी इक्वेशन है इसका ऑर्डर है 2. इसका मतलब क्या हो गया कि मेरे 2 पोल्स हैं जो मेरे लाई करेंगे, मेरे 2 पोल्स होंगे जो मेरे ओरिजिन के अराउंड सिमेट्रिकल होंगे. 2 पोल्स सिमेट्रिकल अबाउट ओरिजिन। अब हम लोग देखो, मेरा जो ऑक्सिलरी इक्वेशन है ये रो हो गया, इसके नीचे चेक करो कोई साइन चेंज है, कोई साइन चेंज नहीं है। ऑक्सिलरी इक्वेशन का रो और इसको ऊपर देखो कोई साइन चेंज है, कोई साइन चेंज नहीं है। इट मीन्स कि मेरा कोई भी पोल्स RHS पे लाई नहीं करेगा, नो पोल्स ऑन RHS। अब देखो कोई पोल RHS पे लाई नहीं करेगा, इसका मतलब क्या हो गया, ये जो मेरे दो रूट्स हैं जो मेरे सिमेट्रिकल है अबाउट ओरिजिन, ये कहाँ पे लाई करेगा। तो देखो दो पोल्स मेरे सिमेट्रिकल अबाउट ओरिजिन होना चाहिए और कोई पोल्स मेरा RHS पे नहीं है। तो अब मेरे पास क्या पॉसिबिलिटी बनता है, मेरे पोल्स कहाँ पे रहेंगे, मेरे पोल्स रहेंगे इमेजिनरी एक्सिस पे, एंड दिस टू पोल्स शैल बी सिमेट्रिकल अबाउट ओरिजिन। ठीक है, तो तीन में से दो पोल तो यहाँ आ गया, अब तीसरा पोल कहाँ रहेगा। ऑब्वियस सी बात है, अगर मेरे कोई पोल्स RHS पे नहीं है तो अब मेरा ये तीसरा पोल रहेगा LHS पे। तो तीनों पोल्स का हम लोगों ने लोकेशन फाइंड आउट कर लिया। तो अगर हम लोग अपने ऑप्शन को देखें तो मेरा ऑप्शन क्या कहता है, मेरा ऑप्शन कह रहा है देखो 2 रूट्स एट, ये भी है इमेजिनरी एक्सिस में, RHS पे तो नहीं है, हाँ 2 रूट्स एट दिस, 1 एट LHS। तो देखो ऑप्शन बी जो है एंड ऑप्शन डी जो है, ये दोनों मेरा सही लग रहा है कि मेरे दोनों पोल्स इमेजिनरी एक्सिस पे है और एक पोल मेरा LHS पे है। अब इन ऑप्शन बी एंड ऑप्शन डी में से करेक्ट ऑप्शन क्या होगा। करेक्ट ऑप्शन के लिए हम लोग को निकालना पड़ेगा कि इमेजिनरी एक्सिस पे मेरा पोल्स कहाँ पे लाई कर रहा है, इमेजिनरी एक्सिस पे मेरा पोल्स कहाँ पे लाई कर रहा है। तो इसके लिए हम लोगों को क्या करना पड़ेगा, इसके लिए हम लोगों को यूज़ करना पड़ेगा अपना ऑक्सिलरी इक्वेशन। तो देखो मेरा ऑक्सिलरी इक्वेशन ये है, तो क्या यहाँ से हम लोग ये चेक कर सकते हैं कि मेरा पोल्स कहाँ पे लाई करेगा। तो देखो यहाँ पे हम लोग देख सकते हैं कि मेरा जो पोल्स लाई कर रहा है वो लाई कर रहा है एट +-j। तो मेरा ऑप्शन बी एंड डी में से क्या करेक्ट ऑप्शन होगा, मेरा ऑप्शन डी इज़ द करेक्ट ऑप्शन कि मेरे दो पोल्स +-j पे लाई करेगा, दैट इज़ इमेजिनरी एक्सिस पे लाई करेगा, एंड एक पोल मेरा LHS पे लाई करेगा। ठीक है, आई होप दिस इज़ क्लियर टू यू। तो चलो आगे चलते हैं। अब चलो नेक्स्ट क्वेश्चन में चलते हैं। तो आपको देखो एक ओपन लूप ट्रांसफ़र फंक्शन दिया गया है और आपको कह रहा है कि कंडीशन ऑफ स्टेबिलिटी निकालने को बोला जा रहा है। तो सबसे पहले हम लोग अपना कैरेक्टरिस्टिक इक्वेशन निकाल देंगे। कैरेक्टरिस्टिक इक्वेशन आ जाएगा S1 - k + 1 + k = 0। अब राउथ टेबल बना लो। तो देखो राउथ टेबल मेरा ये आ जाएगा। अब हम लोग को देखना है कि मेरा स्टेबल सिस्टम स्टेबल कब होगा, जब मेरा जो फर्स्ट कॉलम है वो सारे एलिमेंट्स मेरे पॉजिटिव हो। इट मीन्स कि मेरा हम लोग को क्या मिल जाएगा, 1 + k शुड बी ग्रेटर देन 0, दैट इज k शुड बी ग्रेटर देन -1। ठीक है, ये पहला इक्वेशन आ गया। दूसरा क्या आ रहा है, 1 - k शुड बी ग्रेटर देन 0, दैट इज k शुड बी लेस देन 1। ठीक है, ये आ गया मेरा इक्वेशन 2। फाइनली हम लोग को क्या मिल जाएगा, मेरा k शुड बी ग्रेटर देन -1 लेस देन 1। इसको हम लोग ये भी कह सकते हैं कि मेरा जो मॉड k है, मॉड k शुड बी लेस देन -1। तो मेरा ऑप्शन C इज द करेक्ट ऑप्शन। सो दिस वॉज ऑल अबाउट द राउथ हर्विट्ज क्राइटेरिया। आई होप कि आपको ये लेक्चर पसंद आया होगा। थ्योरी वाइज भी हम लोगों ने बहुत ही कम्प्रिहेंसिव मैनर में चीज़ों को देखा है। जितने भी डिज़ायर्ड ट्रिक्स या कॉन्सेप्ट्स आपको बताना चाहिए था वो मैंने आपको बहुत अच्छे से बता दिया है। प्लस अगर हम लोग क्वेश्चंस का बात करें तो हम लोगों ने प्रीवियस ईयर क्वेश्चंस में जितने भी अच्छे क्वेश्चंस मुझे मिले वो मैंने यहाँ पे आपको कवर करवा दिया है। सो आई होप कि आपका जो राउथ हर्विट्ज क्राइटेरिया है ये आपका एक अच्छे से आपको क्लियर हो गया होगा। अब आप खुद से कुछ प्रीवियस ईयर क्वेश्चंस बनाओ, टेस्ट सीरीज सॉल्व करो और आप देखो कि ये लेक्चर देखकर आपको फ़ायदा हो रहा है कि नहीं हो रहा है। तो चलो नेक्स्ट पार्ट में मिलते हैं।